right now on YouTube. What's the best way to say it here? Hi, everyone. We're about to start now, and we're live on Zoom. And yes, so this is Femi. Femi, would you like to introduce yourself?
Hi, everyone. Yeah, my name is Femi Aziz. Pedro and I co-founded the Istanbul Lagos together. I also work as sorry, not I also work. I work as the head of data science at Pastel Africa. It's an AI company that we do enterprise AI for businesses, fintech businesses for now, and any other businesses that want our AI sets. There are a couple of products for businesses that with things like that. What else you want to know about me?
Okay.
Yeah.
How is the audio?
I like water sports. I like water sports. Every water sports you can think of, probably either learning how to do it or
Okay, thank you, Femi. Can everyone hear us okay? Is my voice, is the volume of my voice okay? Right? All right, so
yeah,
thanks, Chris. I'm going to ask someone, maybe Chris can help me keep an eye on the chats, just in case someone said that they cannot hear us at any point. Just feel free to unmute to say something, because I may not be monitoring the chats as I start the class.
Can you see some camera?
Okay, yes, I can do that. Yes, this is good. All right. So hi, everyone. Welcome to AI Saturdays Lagos session.
So you can see, you should be like this.
Okay.
Yeah.
Okay.
Yeah.
Is it good? Then everyone can see me now. All right. I'm not turning my back towards you. All right, great. When we start chatting, I can turn the camera to the class, and so that you can also see the class. Yeah. Thank you so much. Okay. So hi, everyone. Welcome to AI Saturdays Lagos class. This is what we call one of our workshop series, or like just informal classes, because AI Saturdays Lagos itself, we usually run in cohorts, and that would mean multiple weeks of classes. We have a curriculum that we follow, and I'd say that today I'm going to go through what would typically be day zero curriculum for the AI Saturdays Lagos classes. If we were taking the machine learning cohort or like the deep learning cohort. How many of you have this is my first AI Saturdays Lagos? Can I see hands raised? Okay. Okay, first AI Saturdays Lagos. Welcome to everyone that is new, and welcome back to our host students as well. And my name is Tejumade Afonja, and I am a doctoral researcher at CISPA Helmholtz in Germany. There, I research synthetic tabular data generation with privacy. So my focus is on how to apply rigorous mathematical guarantee to generate synthetic data. And I also am the co-founder of AI Saturdays Lagos. And I co-founded this community with Femi that you just met, is my co-founder, and is going to give a talk later today. In 2018, we started in person, and so far we've organized we've organized 8 cohorts, machine learning and deep learning cohorts. And while we've organized about 2 research cohorts. So it's we have classes for the beginners, intermediates, and our idea of having classes for the people who have gone through the beginner intermediates would be the research cohorts, because now we're thinking about how can we solve problems that we're interested in, and thinking like learning how to read papers together. And you know, at the end of the day, you accumulate knowledge so that you can use it for something, or you accumulate skills because you have a problem in mind and you want the flexibility to be able to solve it. And this brings me to my first question. What is AI? What is artificial intelligence? To you, when you hear that word, what does it mean to you?
Should I talk?
Yes, please.
I think artificial intelligence is the way of machine thinking or reacting like a woman.
Okay. So it's to you, it is a way of us making machine think or act as we would naturally do. Do we have any other definition in the house for that? What does AI mean to you? What is AI? Okay.
I think AI just making that one without explicitly and quoting and explicitly what is action.
Yeah.
I'm reasoning and take
Yeah. Yeah. Yes. Yes. Okay. So if I can rephrase what you said, because AI to you means being able to program system without explicitly programming them, like make things work from, say, you have some experience and you want to learn from it, but you don't want to code it manually, as you would do with any programming language, right? Okay, so this is one very, 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 very acceptable definition of machine learning, for example. And about, like, when you're thinking about the broader system, like AI system, what more do you associate with that terminology, artificial intelligence? We're all correct, by the way. So this is why I'm bringing this up, because you cannot find one definition for AI. And I want to know how you're thinking about AI from different perspectives. Yeah. Yeah. In the class, we got another definition that says that AI is a simulation of what is real. We're trying to say like real life, but it's not really real, but we're just simulating real life. Okay, I'll take one or two from the audience. So Destiny says that AI is a software application that imitates human capabilities. While we have Rukaya also said it's a simulation of human brain, and using algorithm and data that is fed into AI to predict more information. Okay, so yeah. Oh, you're starting the mic out. Okay, very soon. Thank you. What a genius idea. Okay, so do we have any other definition in class?
Sir, ma.
Yes, sir. Abdul Latif, I can hear you. Sorry, I cannot hear you.
Artificial intelligence.
Yeah. Thank you. Can you repeat that, please? Okay. So Oluwatobi said that AI. He said AR. That's AR. What is AR? A system that automatically performs tasks that require human intelligence. Is that your definition of AI, Oluwatobi? When you were talking about AR, like augmented reality, if that's what you mean by AR.
Okay, Teju, um, hello?
Yeah, I can hear you. Go ahead, Lee.
Okay, so if he has not come on, if he's not able to talk now, I know this chat came in when someone was talking about modeling reality, like
Yeah.
so that's when I think he was now putting it as that the AR was exactly, so he has responded.
Okay.
Yeah.
So what you're trying to say is that when we said modeling reality and simulation, that's what we augmented reality, where you have your Googles and you're in your own world, everything else does not matter. Okay, so like I said, we are all correct. This is a definition that I just want you to start thinking about it. Like, what does AI mean to me? We're trying to simulate things like that, like the human brain. When I got into AI, when I started thinking about AI, back in when I was in 200 level, it was because I saw a robot that was roaming around in space, NASA Curiosity rover. I don't know if anyone knows. And I was like, can one build machine that can think? So you can already see that my definition of AI then was like something that can think like the way human, because I see the robots moving around. I'm like, it must be doing some processing and being able to go without anyone moving it around. And I thought that was quite cool to just send something in space and we can coordinate it from wherever we are. And that was what sparked my interest in robotics, being able to take them to mundane places where human sometimes cannot reach, or maybe it's too dangerous, and you just send a robotic agent somewhere to do it. So your why to getting into AI is very different. And this is why I'm asking you, what does AI mean to you? And the other question would be, what do you want it to be for you? What do you want? Why are you trying to learn about AI? Before we move on to more content that I've prepared for you today, I want to hear about your journey, and are you at what stage are you in your AI journey? Are you in the beginner stage or are you more advanced? So if I can just get two people from the class and maybe two from the online audience, we can kind of like have an idea, some statistics. So anyone. Okay.
I will. My name is Monique. So, and I started that's nationally. Then,
so what kind of projects have you built? If you can tell the class an example.
I built a research agent, research assistant. When you have research,
yeah,
your topic content, your content, then generates content based on your starting point. You are also doing that application, Python or Dynamic as well. Also, be predictive models.
Yeah. Amazing. Can you all hear? Well, what did you call your name? Hear me? Okay. Did you hear what he said? Is built so far. Okay. I cannot hear anyone from the class.
No.
No. So he said that he said he's built some applications like RAG applications, some search applications as well, right? With AI, search agents with AI, and like what else? Like what were your stack? And he said he's also done predictive analysis. Okay. So do we have one more person here that would like to share what they've done? Okay. Maybe you come. Can you do you mind making the trip here so that people online can hear a bit more, to make the class a bit more interactive? Thank you. Okay, so,
Or I'm and I'm one now. I got into AI when I got really interested and really invested in AI when I saw a video about Minimax algorithm and really showed me how to use math to simulate and create a model that can something imperfect. And it was very crazy to get that idea of some math to simulate thoughts, human thoughts.
wow,
That was already.
that's so beautifully put. So did you catch everything? Your name is
Video.
Ugbedi
Video.
Ojo. So Ugbedi Ojo said that he got really fascinated in this field and direction when he watched a game where they're using maths to simulate thoughts. It's about a game, right? Min-max algorithm, and it was like, wow, this is so cool to be able to do that. So do we have anyone also online that would like to share? Okay. Doesn't seem like it, but can you all hear me though? If I can get a feedback that you can hear me, that would be great.
Yes, we can hear you.
Okay, great. So for the interest of time, I know we are pressed on time. Let's go into the details of today's class. So I put on this, what will I call it? Like structure, because we usually when we're talking about AI, we have we talked about machine learning interchangeably, and we talk about deep learning, and some people talk about data science. So I just wanted to bring all of those buzzwords here and we unpack it together. So I like to think about AI as the overarching, father or mother. Yeah, universal set. Thank you. The universal set, we say we have AI, and here the definition is any technique which enables computer to mimic human intelligence, which pretty much encapsulates everything that you've all said so far. And then we have machine learning, and machine learning applications, or it's like subset of AI techniques that use statistical methods and you're enabling machine to be able to improve with some experience. And we'll talk about what experience means. Like you need to have something to be able to, some information about the past to be able to predict the future, right? And a deep learning would be like a subset of machine learning, which makes like computation based on some multi-layer of like stacking of different neurons. And here we're really trying, when we say like the deep learning field started, we're trying to simulate the way human brain works actually. But it's not, of course, like human brain is a very complex network. And it's our attempt to have this many layers of neurons interacting together to be able to make better prediction about whatever task or future we want to predict. And there's also data science, right? Data science is a very broad field. You know, if you're coming from a statistic background, you may have heard about a lot of conversation between like statistics and data science. People sometimes in the past, they'll say like, it's very similar, but with data science, we have a lot more data, and that's even some of the statistics earlier, statistical tool may not have been able to handle, but now we have more advanced tools. So it's a cross-disciplinary field that seeks to extract insights from data. What are some everyday AI applications that you can think about? I put some example here. So we say we have a spam detector. Everyone, is everyone using Gmail here? You see some classification happens there. You have your inbox, you have your spam, and so on. And so how would this happen? You have a lot of emails, and then you have a machine learning model, and you learn based on the patterns. You do some classification to have like spam or not spam. So a spam detector that you have in your inbox is an example of everyday AI. Another everyday AI that you may have come across is what? Who here does not know what ChatGPT is? There's no hand up or the online audience. Everyone here knows what ChatGPT is. Also, on the online audience, who doesn't know what ChatGPT is? Someone already asked, what of generative AI agenda? I'm not sure what you mean, Oluwatobi. Would you like to speak?
Yeah, you're giving classes of the AI. You're talking about machine learning, talking about deep learning and data science. I was asking about generative AI.
Oh, generative AI is under deep learning, right? So, yeah, so they are deep neural network models. So it's under deep learning.
Okay, thank you.
No, thanks for that's a great question. Thanks for asking. So everyday I ChatGPT, right? Like chatbots and Gemini and Claude, and they're like a lot now. So what I did before the class, I asked it to write a funny poem about AI Saturday Lagos. Can you all read that, or you can see it clearly? It's like Ode to AI Saturday Lagos, a slightly overfitted poem. In Lagos town on Saturday, when the sun beats down. We should have just said rain. It made a mistake. Today the sun was not beating down. It was raining down. I'll refine it. When the rain was pouring since 6 a.m. in the morning, a group of geeks. I'm not sure if you're geeks. Are you geeks? A group of interested humans begins to meet with Python snacks and code to eat. Well, you can read the rest, but I thought it was funny. I wanted to put it here. We're going to have snacks later. Sorry, online audience. And another one, which is very common application, is sentiment analysis, right? You may have come across it. You have a lot of like reviews, movie reviews, restaurant reviews, and massive amounts of data. How would anyone process it? How do you get insight from you? What is the sentiment of the people that left the review? Is it positive? Is it negative? Is it neutral? So if you know it's negative and then you're having like very poor rating, it means that business will also be slow because people would find that rating and they would move away from whatever you are offering them. But if you have a very high, like a highly rated restaurant or like movie, it's more likely, right, that people would be interested and they would want to watch it. So these are some of the things that you can use, like AI algorithms to help you better gain insights faster, because you have a lot of data. You can think, oh yeah, if we have all of this, we can have a human, they sit down, they look at it one by one, and they decide that, oh, on average, you have very poor rating. This is like, people said they don't like your gekiri. It always makes them poo-poo, sorry, all the time they eat it, or something is happening. So with the age of technology now, and with the tools that we built, you don't need to do that manual work. Mostly you need to, like, say, you label, or if you're doing some tasks, which I'll go into right now. I know some of us are very advanced, and like I said, this is probably going to be like a very like just a refresher for advanced people, but I'm also very cognizant that we have very, very beginner level in the class. So we'll try to do a mix of it all. And another everyday AI would be like the digits recognition, right? Can everyone still hear me, including online people? Please,
Yes, we can hear you.
Let me know. So digits recognition, you want to have a model that can read the number, can recognize it, to give it a picture of a number, and it can tell you that this is a 1 or a 2 or a 3 and so on. So can you think of other AI applications that you have come across that I've not mentioned right now? I'll take 1 or 2 suggestions. AI application that you use, like everyday AI that has not been. I can still think of one right now. What? ChatGPT, but we just mentioned ChatGPT. Yes, ChatGPT for sure. Keypad, exactly. This was what I had in mind, Toby. Keypad prediction. When you're trying to type, hey, it has recognized the way you type to other people, and then it can make prediction of, like, before you finish typing. So it saves you time. Extra keystroke that you needed to press, you don't have to press it anymore. Any other one that you can think? Music recommendation, exactly. So you have like, for those of us that use Spotify, you have like things like you recommend like the curates. It curates a playlist for you based on the things that the music that you listen to. And another one that I can think of right now, recommendation, right? So you go on Konga or Jumia, or I don't know if they still exist right now. I hope so. Where you can like they say people that bought this, or Amazon also bought this other thing. You know, they're using some machine learning to make some prediction to be able to like to be able to predict next. I'm not sharing my screen online. Are you sure? Can everyone see my screen?
Yes. No, we can't see your screen. We are only seeing you.
Oh my God. My goodness. I'm so sorry. Wow. Oh my God. Nobody said anything.
We are seeing it now.
Oh, I'm really sorry. I didn't know. Okay. So this is everything we've done so far, right? I'll share this slide later and you can have a look. Okay.
Where will you show me?
Is it moving now?
Yes, it's moving.
Okay, great. And this was the chatbot that I said we had all day. All right. Okay, we're here. And what was the last thing I said? Recommendation engine, right? Those are other applications that we can think about. Or do we have it? Okay, yeah, go ahead. Yeah. Like you play the music and so they have that thing now. Before you used to use like there's another app that Shazam, right? It's Shazam that you can use to wow. So music, YouTube also has it now. AI is running loose now. So look, you can see we have like it's embedded in a lot of our everyday life, and it means that it's also time for you to like start thinking and being innovative. Like, what can you use AI to do? You know what I mean? Like, if it's there to like help enhance things, or like you can use ChatGPT to ask question, or like to quickly review something. Of course, every there are a lot of downs. Like I'm talking about AI as a very advanced tool right now, and in some ways they are, but in other ways too, you have to be extremely careful, especially with generative AI, because you can have fake news at scale now. I don't know what is true. I don't know what is fake. Let me give you an example. I was chatting with my sister about some opinion. I was like, on the side of the internet that I am on, this is what they said. I had to put that disclaimer because I don't know which side I am. Maybe I'm in my filter bubble like that, and then I'm making like this is it. They should not have given that Grammy to this person. On the side of the internet, we are agreeing this is the direction. So one has to be extra careful. It's like you have to like really do a lot more work to search for them. Not the first thing that you see, and especially nowadays that you have search engines have generative AI there, like the language model. I will give you another example. Why you need to read very well, because there was a time I was arguing with someone about a definition of something. So, but because that's a thing is usual, it's very commonly misunderstood. So when I searched, I was like, see, I'm right, because ChatGPT said you can say it this way. But then I went down, it said, oh, it's a common misconception that this is in this way. And the person I was having the argument with is like, why is this not the first thing that it said before it went ahead to say that what I'm searching for is correct? So if you're too much in a haste, you may end up making rush conclusion. You think you're doing research, but you're lying to yourself. So you have to pay more attention business, but also it's a tool it's a tool that works for some task, and you can use it to your benefits. No, thank you. So the key concept in AI that I want us to think about in class today, like this is the fundamental. I'm trying to teach you fundamentals of AI, but of course, like it's a huge field. But I'm more trying to get you to think about what you think you know or how you use AI, and then what are the basics that maybe you need to brush up upon or something like that. So in my mind, we have like the key concepts in AI is data, algorithms, and model, right? There's a lot more things. Like let's just focus on these three right now. Because without the data, what is AI? Can we do anything? All this Gen AI that we are talking about, do you know how they built it? They look at the entire internet and scraped it. That one self, we can still say another thing, all this ethical thing that, but we will not say that right now. They took the entire internet and scraped it and filtered it. Some humans from Kenya or some other laborers that are not paid very well in some places. I mean, when we want to uncover all those the work, the human that goes into making AI what it is right now, it would be another kind of discussion, because people need to look at some of this information and filter it to have some quality, some level of quality, before we can go ahead to use that into the model. Because, garbage in, what is it? Garbage out, but you feed it with what you give it. If you give it to racist content, you expect AI to not be racist. I mean, how? You know what I mean? Like, there's no magic there. But the thing you will try to do is that, because you can learn a lot using these algorithms can learn a lot of pattern in your data. So you need to make sure that the task is very clear, what you want it to do. And you're not solving a task that that is not what you want to solve, if that makes sense. Is everyone still following me so far? Following me? Okay. So when we're talking about data, data is a collection of values but values of things like information. The most important thing is that it needs to convey what? Information. So the point of having a data point is that you want to retain some information or know something, and information is very, very powerful. It's knowledge, right? That's what makes up the knowledge that you have. So you can have different kind of data from the transportation, like all this, like you can have a data set of the traffic that happens in Lagos itself. Like if you have something to record the movement of cars every day, you can have that and then you have a collection of data, and then you can make prediction to say, okay, at this time, there's always you always have traffic, so don't go at this time. And I'm pretty sure that some of this data is what makes Google Maps better, because over the past couple of years, Google has been in existence for over 20 years, I think. They've collected a lot of data in different regions, and they can make better prediction, right? So we have data in the scientific world as well. Every day you're generating data. The moment you light is back up, NEPA. the moment you leave your house, like you're breathing, like I move from A to B. This is one data point. I go like this, another data. You can be what you're doing is the way I move when I'm giving a presentation. It can be unique to one person, because I might have a unique way of moving or of talking or of addressing the audience. So what other data can you think of that is not listed here on this page? Maybe someone from the online audience. Can you still hear me? No.
Sorry, can you repeat the question?
What other data, like the data that you can think about that doesn't fall under any of these categories on the screen?
We didn't think.
What did you say?
We didn't think that we can have that thing.
Oh, I cannot hear. Can you repeat that?
I don't think that we can have.
Okay, you think everything is well covered here. Someone said
Yes.
education, though. Education, is it? I don't see education here. Yeah, we are, education has, like, there's a lot of data there. Okay, so the other concept that we will talk about is the algorithm, right? So in algorithm, let's talk about the machine learning algorithms. So we have the supervised learning, unsupervised learning, semi-supervised, reinforcement learning. These are the main major one, but we also have like self-supervised learning and so on. But let's focus on this one to understand. So in supervised learning, we usually use labeled data, right? We said we cannot do anything without data, right? So when you have data and then we label the data, let's say you want to make prediction between a dog and a cat. So you collect a lot of data about a cat, a lot of pictures of cats, different position, different kinds of cats, and then you take dogs, different kind of dogs, and then you have their label, dog or cat, right? And to make a prediction, what you will do is like you have an ML model, you feed this data, and then you can classify to either dog or cat, right? So, so as long as you have a label, then you are falling under the supervised learning category, okay? And in unsupervised learning, it means there is no label, right? You don't have any label, you only have your data, and you want to still learn something from your data. So the kind of algorithm that you would think about using when you're in unsupervised setting would be like, maybe you want to cluster something together. Like this is cluster one cluster, this is another cluster, or like you want to do like dimensionality reduction, right? So you have like, you're in a very high dimension and then you want to go down to a very low dimension. So these are some of the algorithms that falls under unsupervised learning. And in semi-supervised learning, we say that we have partly labeled data. Does that make sense? So can anyone give example of what that would look like, What? Like object grouping? Yeah. Okay. Yeah. Yeah. Yeah, so it's similar to this picture that we have here. So we have different kinds of foods, and we only have labels for a few of them. And so we want to also make like be able to label the other ones by training in a semi-supervised manner. So it's like the prediction here, you see the machine learning model where you have the input data, we labeled orange and banana, but we want to be able to like do inference on Apple. So during the training process, at some point we try to tell it that we have an apple also in the data set, or maybe you have one apple and then you use that one apple to label different kinds of apple. You know what I mean? Okay. So, but for reinforcement learning, this is based on the reward, like rewarding some desired behavior and penalizing what you don't want. So here you would have an agent, and then you have the environment, and the agent operates within the environment. The agents would have the state of the agent in that environment, and the agents will perform certain actions. And so this is what you use to reward. You reward good behavior if the agent does what you want it to do. And if it does not, then you penalize it. And this is how the agent learns. You can think about like a small child. How do you correct that child, right? So you like the child does something, maybe they put a hand on something that is hurt right now, they found out that it's hurt, the next time they don't do it. That's a penalization. They found out like there's a signal that says, don't do that. So, yeah, so in supervised learning, we have like classification task and a regression task. An example of classification is the spam classifier that we talked about. While in regression, you have like, say, what to predict house pricing, for example. So then it's a continuous quantity. When you have a continuous label, that's a regression task. But in the classification, it has to be discrete, like boy, girl, yes, no, spam, not spam. So some of the terminologies for the very new people in machine learning, we have the label, like I said, it's the things you're predicting. You have the features, which is the input data. And you have the model, which encodes the relationship between the input features and the label. Okay, so far so good, right? Okay, so and in the training, when we say that we are training, it means that you're trying to teach the model how to do well on your data, right? We are learning based on the experience of past data. And when we say that we are doing inferencing, it means that we have a trained model. And now we are trying to do what? Predict what? What are we trying to do? We have a trained model. Now we're trying to do what? We are trying to do predictions. We want to predict. Yeah. So for the supervised learning algorithm workflow, right? So we have like the raw data, right? And we extract some features. Like I said, we need the features. And then when we have the feature extracted, we train the model. And when we have the trained model, during the training, we try to evaluate the model to see how good it is. Then once we have the trained model that is good enough, then we make predictions. So that's the very classical workflow for supervised learning tasks. Even if you're thinking about generative AI and things like that, or like more advanced deep learning, you still have this similar workflow. You need to have the data, and you need to have a target, like something that you want to get to. So the target could be that you don't have a label of data, but you still have a task that you want to perform, which would be like it would be like dictates how the algorithm would learn from the data. So for the people here that are not like new, what would be the features in this data? The what? Yeah, this is a regression task. So the house price is the what? It's the Y, is a level, that's the feature, right? So the Y will be the house price, while the distance to the nearest market and the presence of the borehole would be the features. And for supervised learning, here, like now I put the answers, this, and I also put some common machine learning algorithm. In Penny's slide in the afternoon, we're going to do a deep dive into one of the three models. But in this class, I will try to talk about the very, very basic model, which is the linear regression, which I think it's what forms the foundation for a lot of people. And within there, we can talk about like optimization or loss function rather. So the linear regression, logistic regression, they are all algorithms.
Please, we can't hear you again.
Yeah, I think it's from my side. I think it's from my side. Probably the network or something.
Yeah.
I think we need to send a message to the chat box so they will be aware we can't see or hear any one of the admin.
Please. Do we have any record or slide after this? Because my own place network is Hello, please, I can't see anything and I can't hear anything in my own side.
Does anybody have maybe anybody in the physical center number? Femi, Teju, Teju sister, or any physical person there?
Or should we send her a mail or something? I'm sure she's not aware that we can hear from the virtual audience.
Yeah, I don't know how we
Yes,
even
I
reach
think we
her.
can send an email. So, but I know she would have realized that we are not joining because she might ask those who are virtual questions, and since we're not able to answer, she will realize that we can't actually start connecting possibly. So
Yeah.
it might be network because I think she said it's raining heavily there.
Yes, yes.
Just check the YouTube platform as well. It's down also.
Yeah.
So the general. Yeah.
No, it's about that.
Please, can we see any slide or any recording that we will use to cover all the events that you did? Because I personally, I didn't see anything again. Now, please.
Hi, thank you all for still staying on. It was helpful, like a long time. We had a lot of technical problems, so
I
we
think
moved
there's
rooms.
enough chair for everyone.
This is an extra.
There's an extra chair. There's enough chair for everyone.
Can everyone still hear me?
Yes, yes, ma.
Okay, all right. Thank you.
You're back now.
I can
Please,
try to record this session maybe sometimes in the future and put it on YouTube in case we still have some disruption. But for now, I'm not going to start the live stream anymore. Okay, I hope that's fine.
Okay.
Okay. Next time. Okay, so where was we were talking about what was the last thing I talked about? Regularization, right? Right? So can someone tell me now, like, why would you need to regularize? So how did we get there so that we can explain the online summary of what we've talked about so far? Anyone? Okay.
About overfitting.
Please speak up a little bit because so that people can hear.
There's something about data and overfitting.
Oh, my goodness.
So Johnson,
Hi.
Wow. So
Oh my God.
You'll be all right. Welcome to Nigeria. Yeah. Yeah, thank you very much for the microphone.
Thank you so much.
Thank you so much.
Okay. Sorry guys for the noise. I think it's good now. Can you still hear us?
Yes, we can. We can hear you clearly.
Yes.
Talking about linear regression and fitting in modules with data, and then talking about if there's no linear regression, how can you try to make sure it fits new feature engineering use the level features for so that breaks down appropriate implications for that. And then we'll talk about what happens like the end of the overfitting, and we talk about different ways you can address overfitting. You can use more data, you can reduce the features that you're using, and you can also use regularization.
Oh my God, best students. Thank you so much. You summarized it so beautifully. Okay. So far this is where we have, but can you all see my screen? Am I sharing now?
No.
Anything? Not yet. Okay, let's do that now. All right.
We have
Okay.
seen it.
Yes, so this was a slide where we were looking at, we were talking about common machine learning algorithm. And I said that, sorry. And I said, don't you think this thing is like overkill? And is it okay? Should I use the word? Okay. And I said that, thank you. And I said that later on, Femi is going to go through one of the 3 algorithms more in depth. So I really do hope that for people that don't know how it works, they can learn it from that. But what I will focus on right now is to talk about linear regression, because like, even if you know Gen AI, you are doing everything, you know, like Ninja on prompting ChatGPT. I think linear regression is really, really basics and basic of it. And so let's spend some time trying to understand that. Then we also have this naive Bayes algorithm, and those algorithms are supervised. We have support vector machines and k-means clustering, and all of those are unsupervised model. For neural networks, you could have like supervised tasks or not unsupervised tasks or semi-supervised. It's like a lot more we can do that. Okay, so let's look at the third one, which is the model, right? And I said we'll talk about linear regression. We already started talking about the equation of a straight line. This is what I asked you earlier. I said, tell me the equation of a straight line. And we all remember our y equals to mx plus c. The m stands for the gradient or the slope. What does that mean? It just tells you how steep, right? How steep the line is. So if I have a question for you, if we have the line like this, it's a straight line horizontal, what would be the gradient? Oh, sharp. People don't want to look after you. Oh, sorry, for people that don't understand Yoruba. I said this, translate this, Shadrach. Yes, yeah, for sure. So if you have an horizontal, there's no gradient because I just said that gradient tells you how steep the line is. So and it's also like if you move your data, if your data is following a certain path and you want to classify between one class or another, and you put those data into a space. Right now, let's say it's a two-dimensional space. So you could see blue class here and green class in the other side. What you would want to do is to like pick a straight line to be in between them that maximizes the distance between what we call a decision boundary and the different classes. So that's how the logistic regression algorithm, that's how it would want to do the classification. But if you're looking at support vector machine as well, it also tries to find the maximum distance between the decision boundary and the two different classes. Essentially, what you're trying to do is that I have two classes, I want to classify them. Like I want to be able to know that if I have a data point that falls in this point, what would be the class? I know I'm doing imaginary movements of hand now. Just think of this as the class 1 and this side as class 2. And if the data falls somewhere here, what should be the prediction? Yeah, class. This is class 2 here. Class 1, exactly. So class 1. So but here we are focusing on linear regression, right? So it means that we have a what does our target look like? If we're looking at linear regression, what is it? What kind of target are we modeling? A continuous target, right? Something like house prices that we just looked at. So and this is like you already know this, like if you have these two lines, and the first line is 2x plus 1 equation. This is the equation of that line, and the other one is 2x minus 2. And if you wanted to look at the intercept, it's where it intersects the y-axis. You can see this is exactly 1, and this is this is 1, and this is minus 2, right? You can see that this is where the intercept happens, and this is how it translates to that equation of that line. And what will give you that the other one, this value, the value that is let's go back here, the 2 here. How you would know that it's as the slope of 2 is, you have to do some calculation. You look at the gradient, the change in the y direction over change in x direction. These are some of the fundamentals that many of us have from way back, secondary school or something, but this is a refresher. And all of this information is very important because we rely on them when we start to think about a very advanced machine learning models. Like if you're thinking about a deep neural network, you're like, okay, you have gradients, then how do you move within that gradient? So you have like a lost curve, a lost landscape, and you're navigating, you're trying to find where the loss is minimal, because if you have minimal loss, right, that is what would help you optimal solution, right? Optimization. So you can see when people say that in linear regression, in machine learning, you have some basic fundamentals that you need to learn. You acquire those things in school, but because you're not relating it to a particular problem, you may not, pay too much attention. So this is why it's important to come back to think from that direction, because as you're learning, as you're building, it will also inform the kind of algorithms that you would come up with. You know, people came up with this algorithm, did not drop from the sky. You know, you can also sit down and think about the kind of problem that we have in Nigeria. And you're like, maybe it used to be like this, our data is always like, it will go up and then it will go in certain directions. Maybe there's some algorithm that we can come up with, like a measure of everything that will fit the kind of data that we have better, you know, and you will optimize it. So I'm looking forward to when I read like such invention coming from you guys. Just tag me, remember. So, or maybe we'll do it together, who knows? So let's look at a very practical scenario, right? I pulled this data from the Open Africa data set. It's called food prices from 2017 to 2021. We don't have a lot of time here, but I also prepared a notebook for you guys. So if you go to that notebook and you click on that link, you will find I've prepared the data. I have some buttons that you can toggle, and you can look at the different like the data. So on the y-axis, I'm so sorry, this is bad. Don't be like me. You should label your x and y-axis. On the y-axis is the price of that food item. The title says granules, 1 bottle, specified bottle. So that is what the data gave it. So it's like, that is the price of granule oil, 1 bottle. As of January 17, which year is that? 2017, God bless you. I think it's January 2017, as of January 2017, the price was less than 500 naira, because it's Nigerian food, so it's naira. And now, in this economy, even though this has gone, it's not 2025, as of November 2021, the price of granule oil was almost 1,000. See, how much is it now? 2,000. Does everybody's going up? Yeah, you can see that the thing is just going, it started small, it's going up. Can you make prediction for how it's going to be in the next 2 years? You don't know. But we have machine learning algorithm now we can use it. Can we model it? Can we predict? Because if we know, we know the kind of hustle we should be hustling now. Granule oil, we should keep it in the house for a while. I sell it when it's there, that's rice. So these are the kind of insights you can gather with data. You look at it, where were we in the past? Another on another slide that I gave a similar talk somewhere else. I put the inflation rates side by side. It's like, if you have this, is this going up when inflation is going up? Because it's like, you think that if inflation goes up, maybe price also will go up, because everyone is like, we're all suffering together. The person that will go and collect the price, the grant on somewhere, it's not like they will give them for free. So as I'm saying, so you can also like look at different, you can see rice there, you can see Gary. It just shows you, it visualizes how much change, like as in one of the data, I think Gary or something, it went up at some point and then came down and then went up and came down. It's like almost sinusoidal and then went up. So if you want to now say, let's now fit a straight line, you first have to find the kind of straight line to fit, right? Now we only have one feature. Can someone tell me the feature here? Right. Yes, the price is the feature. I'll let you think about it again. Yes, I need to think about it again. So the price is the target, it's what we want to know. It said based on January 2017, we know that we paid 500 naira. And then in the next, what happened? In 2021, this is how much, almost 1,000. Then we want to say, what will it be in 2029? And that is what you can, if you fit, let's say, a linear, if you think that it's following a linear relationship and you fit a linear model on it, then you can make a prediction for that. So, how are we doing? Okay. By the way, any questions so far, online audience? Has anyone been able to click on that notebook and run it? You can just click on it and do run all. Have you been able to do it? Feedback.
Okay, I also able to click it too. I don't know why. I was trying to see how I could, and probably you could share the link in the chat or something.
Okay, it should be easier to share the link. Let me do it. Let's try to find the
voltage drop.
whole app. Okay. Okay. I think we are back now. But has anyone clicked on that link yet, or you also waiting for me to share the link properly on chat?
No. So if you can help out with just copying the link from the slides to the chat, I think that would help.
Let me drop the link in the chat then, so y'all can also see it. Oh, we're still on YouTube. Oh, okay. Nice. Okay, now the link is in the chat, but maybe you also try to join online so that you can get it's easier for me to share the anyway, so when you click on that link, you should get into the notebook and you should be able to see this particular one here, and you should be able to toggle as I was saying. But I just want 1 or 2 people to tell me that they've been able to do that, then we can move on to our storytelling session. Anyone? Should I share the link again? Yeah. Okay. You can access it. Can you run on?
Yes.
Run on. Can you run on?
Okay. Okay.
Yeah. Are you able to toggle to check the different prices?
4, 5.
Yes, so you can see it now. Like, yeah. If you go, there's a button that you can press, and then it's running. It's running now. Can I do? So when you go here, you can see the button. Or maybe I should I show it here? Do you want to spend time? Okay.
Please, did you mean that the link will show in front of our screen right
Okay. Now? Yes. No. So let me do it. Let me show you what I'm doing. So maybe it's easier that way. I didn't want to stop sharing my but let's do it together then. Since I'm here. So when we go here, this is the link I shared. This one here. Can you see what I'm sharing?
Yes.
Okay. So I said when you come to this notebook, all I want you to do for me is to run all. See? By the way, as I said, I gave this talk. I'm not presenting my screen. Oh my God. Hey, please tell me, online audience, when you can't see my screen. I don't know. I'm so sorry. It's not intentional. Okay. Let me show again. When it disconnected. When last did you see my screen?
It has been long.
Immediately the TV went off.
Okay. Sorry, we are in this together today. I'm so sorry. Like I said, I put the link on the chat. Let me do it again. Or someone can someone put the link on chat again?
Yeah, the link is still on the chat.
It's just for people that are just joining me. I'll put it again. Okay, so, but can you see what I'm seeing now? Everyone, online audience, can you see it? So if you come here, I just want you to run all. Are you able to run all?
Yes, I was able to run all.
So you can see that you can all like I'm hiding a lot of code here, but you can unhide it. So some of those code is how I downloaded the data set. I went to Open Africa and I just get to get the data from there. And once it downloaded it on my computer. Sorry, on my Colab rather. And this is a Google Colab for those of us that this is the first time you are seeing this kind of Colab. Then I did some cleaning, like with some pandas, and then you can see that I'm showing you, this is what the data looks like. It has the different year, month. It has the different year and month, and if you now come here, so can you toggle? So this is for agric eggs, medium price for one. Look at what the data looks like. In January 17, it's about 47.5. Let's say it's like 47,000 or something. I'm not sure the units this is in. I should go look at the data description. So 47.5 is what they at January. And then at some point it went down and then it went up as well. And if you go to another data point, you see, it went high and then went low, then went high, it's going high again. You can see that all of this data has like different shape, right? Different kind of model would work for it. So this, I just want you to see that you first need to understand like what does your data look like, right? Like what kind of distribution, what kind of model do you think that may work? This is easier. We are visualizing, it's just one feature, but usually you have like thousands of features. There's no way you can make sense of it that way. So you just have to make some assumption, usually like a Gaussian assumption, you know, like from this distribution, and then you fit some, you try some algorithm, and then if you find that it's not predicting well based on the different features that you give it, you try to do feature engineering if it's classical machine learning. But if you're working with deep learning algorithms, then you're extracting extracting the feature in a different way, like using say I'm going to get there. I don't want to talk like deep learning is computer vision, like NLP. I have a slide that kind of like just shows that. So this is why I'm a bit ahead of myself here. So let's quickly move forward and see where we can get to before Femi take over. So I was, I was on presenter view because I want to have something here for me to look at as well. Let's move it to the side. Is it the other side? Okay. Thank you. All right. So let's continue then. Can everyone still see my screen online? Okay. So if you try to fit a straight line now on price of groundnut oil, it kind of like look like a linear, right? Linear relationship. So this is like you're able to do that, and then if you make a new prediction, say, as the way your linear, the linear model is going, you can say that the line will still be going like this. It's going to be getting all this wrong for sure. But if for some reason the price goes down as well, then you may be able to predict, forecast what the next one would be. Okay, so like this is a lot of text, but linear regression is a simple machine learning algorithm that is used to model the relationship between some dependent variable and one or more independent. Dependent would be the target, as we're saying, and independent variable would be your features. And it's usually used for numerical. And this is the same equation that we saw before. In machine learning, we usually write it like B plus W. W becomes the weight, and X1, X2 to Xn would be the number of features that you have. And your B is the bias, as we said before. And but you're not only dealing with one feature, mostly. You have multiple features. So this is what the equation will look like. It's still an additive. You have the bias W0, then plus W1, X1, and each of the weights is for the feature. So you learn a weight for each features of your data, because this is what you use to be able to model that data, right? Those are the weights that you change. And I have a question here. What do you think? Which of these two lines do you think fits the data better? The second one. Why do you think so? It's closer to the data, right? You just eyeballed it. It's like, but the first one, like, you think it's, yeah, okay, you're right. But you're right, but let's look at why you're right. So I'm coming into another crucial concept. You see, I'm going through it in a way that when you're thinking about, we start with data, you talked about algorithm. Now you have algorithm, you fitted the model, right? You have something, you have a line. Now you're like, you have two lines. How do you know which line is better, right? And this better is a concept that we call loss, right? Like we can measure that using like a quantitative value, so like the loss function, and you can calculate that. So loss is a penalty for bad prediction, like what helps the model to get better. So when your loss is low, it means that your model is getting things wrong, not getting a lot of things wrong. It's very good, in short. But when your loss is very high, it means you're making a lot of mistakes. And so when you're training the model, you're trying to learn a set of values or weights that reduces the loss. So we have this two model now, and I'll show you how you would want to calculate the loss for that, right? So let's say we choose this year, June 20th, and then you measure the loss, right? You look at the targets. This is the target, what you want to predict. This is what you ended up predicting. It's the gap between that, right? So let's put it out. We get this line, we take it out, and then we take another data point, the target, and we look at the distance between the target and the prediction. So the different. Then we look at the third one as well. So then, if we have everything, this makes up your loss, how wrong for those three data points. Of course, it's going to be accumulated across all the data points, but for now, let's look at this three. And then let's look at the same data point in this, see how far it is, and you can see how much how much gap you can say. So this is just illustrates to you like how you're thinking about the difference and how to calculate like the loss function that you use mostly for regression is called the mean squared error, right? And how many of you have heard of mean squared error? Yeah, some of us, about 2 or 3 people, out of how many people? Or some of us are not saying anything because you know all of this already, right? Okay. Okay, so exactly. So this is big, this is small. So that is why the line that you think is the best because the loss error, the mistakes that the model is making is minimal for that line. So this is the equation, the mean squared error. The y hat, the one with the hat, would be the prediction that you're making. So this is like this line here. This data, here will be the y hat, and this is the y. This is which is called your what? What is your y? What? From the back. They're not listening, no. You see, what is y? Your actual value, exactly. And then what is this? Your actual value minus what? Your predicted value squared, right?
Yeah.
And you can see where the squared error comes from. That is the SE. Squared error is what? Actual value minus predicted value squared. Then you do what? You sum it up across all your data points. M is the number of data points that you have. Then the mean comes from doing what?
Divided by number.
Divided by the number of data points. So that's why it's called the mean squared error. So you all know this thing. Can I give the mic to you? Yeah. So when you have your error, right? I also just wanted to know, again, I'm walking through what I think is fundamental. So thinking about like machine learning or AI. So you need to always have not just your training set, you need to have your testing set, because how do you know, we talked about generalization, right? So if you have learned everything on your training data and you said you have a perfect model, but where the test of the exam, our exam used to be different from what you did in class. The test is what, when you have your exam and then you bring in unseen data, how does that model perform? And the test data is usually, you should keep it, lock it in a room and throw the key away. No, don't do that. Don't throw the key away because you still need to remember where the key is. So once you are done with your modeling, then you have to use your test data to now to see how well it does. But during your modeling, you also usually keep another pot of data to use to test small, and that's called, does anyone know what that pot of data is called? Validation data, exactly. Okay, so this is an illustration of that. See, we trained the model from January 19, right? To November, January 2019 to November 2021. And it looks like a linear fitted, right? But I now decided to go back in time. Let's see if that model would have been able to predict well what we had in the past. What do you think? This is unseen data. This is a very bad model. See, very, very bad model. So you can see, like, if we had used the entire data, like the model saw it, the prediction would have been a bit different. But again, well, it's still going to only fit that. We still need some way of testing that the line that we have is a good line. Okay, so we talked about this generalization. So when we trained on we trained the model on the training data, and then okay, yeah, I've made a mistake here. You see the polynomial features data, it's not here right now. And this is what the curve look like, the overfitting curve, where you have the validation data and the trained data. And so you want to get to make sure that when can you tell me at what point do you think this model is already overfitting? When it starts over? Going up from the training data. Okay, yeah, I'm trying to. Yeah, so when it started to go up using the validation data, right? You can see I'm not calling it test data. You should not be testing this thing, because otherwise your test data is also polluted, because to do any of this making your model better, which we call hyperparameter tuning and everything, you need to use your validation data. Should be a different one. Okay, so so when it starts to go up is when you're starting to overfit. Ideally, one of the ways to combat that would be to do what? Yeah, but if you like, early stopping is also you could have just stopped here, right? It has not overfitted yet at this point. So instead of going all the way to this like number of iteration that we don't know here, you can just stop here, just when it starts, before it starts to overfit the model. So okay, so some of the mathematical foundations that we've talked about, that I've talked about, I've said distribution, right? I said Gaussian. We've talked about we've seen linear algebra in action, actually, looking at the x and y and the mean squared error. So all of that matrix multiplication, dot multiplication, those are like under linear algebra. So it's a branch of mathematics that deals with the study of vectors and mathematics go back. Then those are considered the very, very mathematical foundation in which you need when you're working in this field. And then the probability and statistics is also something that you should brush up on. Understand the different distribution. What can it do? Like what kind of data models age of the entire population? If you study statistics, you could probably know the answer to this. Like, is it uniform or Gaussian? Is it not normal? It's a normal distribution, right? Which is also Gaussian. Yeah, it's a normal. Yeah, that's a normal distribution. It's a uniform distribution, just goes like this. Are we saying that the age of everyone is like flat? Yeah. So it's a normal, or normal is like also like similar to Gaussian distribution. It's just normal distribution. I think has mean of 0 and standard deviation of 1. But what I want to say is that if you understand like how distribution works, we also have Laplace distribution. We also have all this other popular distribution. When you're thinking about time series, does anyone remember which distribution is more Poisson?
Fourier.
Fourier. So there's like so many of them, and it's worth investing time to understand them. And in the beginning, it may seem like very daunting, but as you continue, I think we're having another class in the back. Can someone tell me what's happening? Yeah, what is it now? Look me in. What is it that you want me to know? We're talking about statistics. So what are the things that you thought about, like they were taught? You don't like statistics? Okay. You start crying. La cam, la pour, la delete. But these are the things that it's. I mean, I know what you like. We've all been there and done that, but come back. But the more you start to get into this field, the more you understand that you need those foundations, and you use them actually. You think about them. You start to you have some equation. Like I told you, I work in like privacy and machine learning and synthetic data generation. And so when we're in there, we're like thinking about what kind of noise are you adding? And you don't want to add you want to add enough noise, but not destroying the signal in the data. So it's like you're drawing what kind of guarantee can you give? You're drawing noise from the Gaussian distribution, or is it a Laplace guarantee? So you're thinking very foundational. And so you have to go back to try to understand how that works. So if you're into research, this is actually very important and helpful. Help you become a better researcher. And optimization is also something that you would use in machine learning. You cannot run away from optimization. You know what I mean? So all of these things that we're saying that you want to get the loss to be low, how do you get it to be low? Like you have a certain, you had the first that one that was added a bigger loss. How would the model, how would you take that line down? We've talked about gradients, right? You look at the gradients and then you adjust the line, and all of those adjustments that I'm talking about, you're optimizing to make sure that the model fits perfectly. And so optimization is also a field, a well-established field that is focused on finding the best solution, right? It could be the maximum or the minimum, but usually in machine learning, you're looking for where the loss is minimal, which is the minimum, given your problem. So this is if you look at this, you have, let's say this is your loss landscape, and you want to get to the minimum here. This is a convex loss, by the way. This is why you have one minimum like this. So this loss landscape, what you would do, you will start from some points. Let's say your first gradient, that W1, the first number that you got, it puts you here, but you want to get here. But how do you navigate? You start to go, you measure the loss, you calculate, you draw some line, you calculate the gradient, and it's like, oh, you go opposite, you want to go down. So you do gradient descent and you start to try to go down by doing that. And so at some point you get to this minimum. I've not put the old formula there and everything because I know a lot of the audience are very new, but honestly, this is very, very, very foundational and you should never stop here. So we have an entire cohort where we went through like the different parts. Like I had the class, just one class on linear algebra. There's a class on probability and statistics. There's class on introduction to machine learning, which covers gradient descent and so on. So this, they also common evaluation ways, like once you have a model that is trained, you want to evaluate it. You want to take it to the wild, and you would like have things like accuracy, how well, how many of the prediction did you get well? Like you want to predict 5, you got 4 out of 5. That's your accuracy, right? But accuracy also is not enough, depending on whether or not. Can someone tell me when accuracy is bad? Can be bad. Like, you know, I said accuracy is not enough. What happens? Why would you want to consider other kind of metrics? Yeah, imbalance. Yeah, this is this. Come and sit here and let's come and teach. Yeah, I'm just checking. So exactly when you have imbalanced data, so it means like one class is bigger than the other, your accuracy becomes not reliable. It's like this is something called accuracy paradox, if you've heard of it. So, you know, you want to look at other things like precisional recall that looks at your true positive, like for precision, how many of the models positive prediction are actually correct, or like how many, like out of your entire positive, how many was actually correctly identified. And there's also like you know, this is if you're like looking at supervised learning tasks, you also have like confusion metrics, right? Where you have like your true positive, like it's a grid, true positive, true negative, false positive. Exactly. To just help you see like where is my model getting it wrong, to know what to focus on. Okay, so we're almost at the end. This is this was the polynomial feature that I talked about, right? So here I'm looking at polynomial of degree up to 20, and you can see that we are fitting the model better here, but it's really, really bad on the unseen data. And also here, it's really, really bad. So I put in that notebook, you can play around with it. You can think of how to make a model, like the model better on that particular data, but I want you to keep some test sets separate and try to see what kind of features can you use that would help you predict well the price of groundnut oil. So okay, oh, this is really bad. Sorry. So in deep learning, like in machine learning, usually you have like you extract your features. Sometimes manually you have a table that shows you the different features. Or in deep learning, you actually just once you have the data, you use a neural network to extract the features within it. So you don't craft it like that. And examples, you have like convolutional neural network, where you start a lot of channels. Does anyone know like who here have like knowledge about convolutional neural network? A little bit, you know more. It's not idea. I know you're a professor. Many people. Who else? Idea. An idea. Tell me your idea about convolutional neural network. Yeah. What is the idea? Okay.
Input, like
yeah.
input and output.
Yeah.
Together.
So
there's a system.
Yeah.
That relates the input and system. Combining the input and the system.
And what are those systems? What's happening in between? Okay, idea. Okay. Professor One, tell me what's your understanding of convolution?
Okay. What I know about convolution,
yeah.
For image.
Yes.
So when you feed in an image, it's the convolutional analysis.
Yeah.
So the convolutional handle is to keeps moving, and then pulls out the
Yes.
from
Yeah.
image,
Yeah.
and then okay.
Yeah, you can. Yeah. It's already here, right? Like through the cat.
Yeah,
I've given you expo.
so these are so the convolutional, so the convolutional handle now
Yeah.
moves across the image, and then then now you remove picture, and then now you can mask pulling.
Yeah.
This direction now, maybe
Yeah.
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 Another convolution, another term is occurring again, which
Yeah.
how
Yeah.
using the
So you just keep extracting features, and depending on how deep the network is, or like it also informs how much like features you can extract. Yes. So, but this is like you have something you want to tell me, Auntie? What is it? Huh? Okay. It seems like there's a class going on at the back. All right. Okay. So yeah, it's what you said. And when you have an input data, and then you're trying to extract features and patches, those kernels that you see there, like this you have like the different channels here up to 24, and then you have kernels, and then you just keep moving around the image, and like you can have a particular feature which is just looking at a certain line. Early on in the neurons, the features are very foundational, like let's say line or like a small curve or something. But as you go deeper, it starts to combine to make maybe the eye line or the shape of if you were trying to predict the face. In this case of two, it could combine to say maybe there's a feature that recognizes the curve on part or the top curve. And as you go to the end of by the end, like the layers towards the bottleneck, which is the fully connected layer, you're going to start to see more structure. So we'll be looking like it's almost two. So that's like convolution, and it's just mimicking the prior that it has is like it's how to recognize objects within the image. So that the way the kernels are constructed. So we also have another deep neural network like diffusion. Like I know anyone has tried to generate. Did you know like this website called "This Face Does Not Exist"? That uses GAN, by the way. But have you come across that website? It's called thispersondoesnotexist.com. Is this still alive? Can you Google it? Thispersondoesnotexist.com. It's been a long time since I went to that website, but does it still work? Yes, you can see different person. If you refresh, you see someone else. Those are generated images, but it uses a GAN, generative adversarial network, not diffusion that I'm showing you here. So diffusion is also another powerful generative model, but that uses like we have like encoder, decoder. You may have also heard of a variation or auto encoder, VAE. They're all in the family of generative model. What does it mean to generate something? You like we were talking before about tasks where it's supervised, right? You have the input and you want to predict a level. But here we're trying to do what? We're trying to get a distribution from noise. That's where you have the GAN. But when you have like VAE, you add noise in the forward process. Diffusion rather. You had noise in the forward process, and then as you're going in the backward process, you'll try to remove the noise, and that's like the diffusion process. But you can also even have like a text encoder. Like do you know of DALL-E? Like DALL-E, like all this genre, yes, where you can just text it, and even this Google BEO that they just announced, you write the text like generates a text, it generates a man dancing komole or something like that, and generates a video, or like some two Agias at the back chatting and not listening to the instructor. They'll generate that as well. No, they're listening, but they're chatting, right? They're listening. Okay, so that's like the diffusion model, and we also have like I guess I put a slide for NLP, but of course we also have like transformer architecture and so on. So this is my last slide that is critical to what I want to talk about right now. So do you have any questions so far?
Please, I have a question.
Sorry, one moment. Yeah. Yeah. Yes, test data usually. So when you keep test data and you're meant to only use it once at the end of you've done all your modeling, and you just want, before you deploy it, for example, you want to see what's the performance. That is like your test data. And in fact, when you've done it, when you want to do another modeling, you should collect another test data. So the whole point is that you don't want to pollute your test data. But for validation, it's similar to test data in the sense that you don't use it in the training, but you're always using it to correct your model. If you were choosing a lot of hyperparameters, there are some algorithms that the default does not just work. You need to fine tune them to your data set, the kind of data that you have. Like, so let's say in the tree algorithm, you can have like the number of depths, how deep you want the tree to be, or how, like what else is the algorithm, like the kind of, what is it called? Leaves, and I'm talking about tree algorithms. I'm trying to remember the one other, something in my head. It's not coming out very well. No, I was to talk about the nodes. The node is also one hyperparameter that you need to tune. The what? Depth. Yeah, we talked about the depth. It's also an hyperparameter to tune, or even the way that the tree is being constructed. What is that thing called? Like, minimum split. That's also hyperparameter. I'm trying to remember the algorithm itself that you need, because you can also change that, but it's not from the method of traversing the trees. I think that's also some parameter there. But okay, I'm talking like but even within that algorithm, you have so many things you can tune, and this is where like the validation test can really help you, because you use it to do hyperparameter search to find the optimal values for your model.
So what are the sources for the test data?
The what? The sources for the test data. Can you come?
You said this or not?
Yeah.
So where would we get the test data?
You should have kept it, like you should have splitted it. So usually you split into three. I showed two splits right now. Depending on how big your data set is, what people do in normal workflow, you split into three. You keep maybe like a 10% for your test and 10% for validation or something, depending on how big your data is actually. Then you keep that one aside. When you're done with the entire modeling, you test on your test data. So this is the standard process for but if you don't have enough data, you can do things like cross-validation. Does anyone know what cross-validation is? Yeah, all right, cross-validation. So that also can help you, like then you're still able to get variance in the performance of your model. So there's also things called like bias and variance trade-off, in machine learning. Any question from the other Abdulaziz, rather?
Now, please, my side, the network is not is poor, so it makes a lot of video that you are doing. Please, can I get a recording for all these video or whatever?
Okay. Yes, yes. You know, what I can do is to give it, I'll try like, yeah, not, I don't have a recording right now, but I'll try to make a recording that is clean and then share if a lot of people are interested in that. Okay, Damlola. So Abdullah, please, yeah, I'll try to do that hopefully in the next
All right.
month.
Okay.
Yeah.
Thank you. Okay. Yeah. So thank you so much, Teju. It's been an amazing class. So I just wanted to take a few steps back. When you were actually discussing ternary neural network, I don't know if I didn't get any kind of use case in terms of application adoption. When do we use this kind of framework? Just like an example of when this, or an example of convolutional neural network. Or when is it adoptable? In what context? It could be in videos or something such as, yeah. So I just wanted context so that it will stick. Another question also is this. I think one of the beautiful thing about your classes is that you tend to, you give this sense of ML is not a big ideology as it seems. So I love the beauty of, you trying to give us the maths foundation and all that. So so there's another question that have been bothering my heart in terms of concept of perception, bias, and also, so there's this work a research work I'm trying to work on, and we're trying to model perception and compliance and also bias mathematically. So how do you think I should approach solving that? So we're modeling perception of people in terms of gathering data and their feedback. So how do we model it starting out?
That's a great question, Damlola. Thanks. So for the first one, I earlier on when I started the presentation, we talked about like everyday AI, and one of those things I mentioned is like I said, digitization. So we were like, how do we relate these algorithms to use case? And if you were trying to do like a digit recognition task right now, you would want to use, mostly people use convolutional neural network because it works on images, right? And you want to recognize you want to classify the different digits based on the picture that you have. So convolutional neural network is mostly algorithm that you think of when you're dealing with images. But some people also use convolutions for tables. I've seen it being used actually in some of the work that I did for synthetic tabular data generation. There was some earlier work that used 1D convolution to be able to like to train that model in like using generative adversarial network and so on, GAN model. So the GAN, the architecture within it is 1D convolution stacked up together. And for NLP now, for diffusion, we talked about like DALL-E, like this is one application that I can think of. This is like they use diffusion models, but you can also use diffusion for other kind of modality. You can think of speech data. You can think of it's about how you represent your data when you start with. So the point is that what kind of task do you want to do, and what kind of algorithm has the priors that you can leverage to do the tasks very well. And convolution has encoded a lot of priors for images, and this is why it works very well. While the transformers architecture has encoded a lot of priors for language, this is why it's used a lot for language. Does that make sense?
Yes. Thank you so much.
You're very welcome. And we talk about bias and like compliance, and it's true that we talked a lot about how ML is, it's easy, anyone can do it, but there's a lot of ethical concerns. I talked about this a little bit when we were talking like fake news and how you have to double check everything these days and not just rely on the first thing. But like bias is everywhere. There's like like lots of researchers and like that are forced to make sure that a lot of these models have encoding our values, the values of like everyone, not just the Americans, because that's where a lot of the models are being built. And it's only natural that when you're building something, you know a lot about your own surrounding, but if you're building a global model, it's also within your responsibility as an organization to put people in places that you want to serve and to collect the data there so that you can be able to address their needs more. And so a biases shows up in these algorithms where maybe the very popular one is facial recognition that Google facial recognition there was recognizing. I think like a woman, a Black woman, something like that, and they fixed that quickly. To think that would even go out without being tested, it means like there was a flaw in the testing, like when they were testing before it went out. But the people build it into humans like us as well. So it's like if at that time they didn't have like Black engineers or researchers within them, they would not have, might not have crossed them. I'm not making excuses for anyone. Everyone should be held accountable for actions. But I just wanted to make a point for why diversity is extremely important in your organization, like the values of men and the female. You were asking about whether or not how would I go about modeling the perspective of people, right? This was your question?
Yes.
Bias. Well, I think I would need to understand a bit more about the task you're trying to solve, honestly, to be able to answer that in depth, better. Because from this few points that we talked about, I cannot give one answer. And maybe this is what we should do, try to understand. Maybe we can have another call. You can have a meeting at some point. But I don't know enough to be able to tell you how to do it.
All right. Thank you so much.
Yeah.
I think, yeah.
Yeah, thank you. Okay, so do we have another question?
Yes.
Okay, sorry,
Please,
Abdullah.
I said, can we have any beginner group that I can join? Did you have any beginner group?
Yes, we do have a Discord channel, and I can share it after the class, and I can make like a beginner group. So people who are very beginner, they can ask their questions, and we can even have like what's it called? Like some meeting to like what is that thing? Good to. Yeah, Google Groups, but it's for everyone, right? I said we can use Discord to have like it's thinking about like a channel for beginners. I think it's actually quite helpful. So we don't put everyone in one bucket. People are like in different. We can also have advanced people join to answer questions or like we guide. But yes, after that phase, I'm taking your point and we will consider that. Okay, I'll send out the Discord channel later. All right. Okay. I think now we need to come to a short break. And then Femi would come back to give the hands-on. Like it's going to take roughly about 1 hour, 30 minutes to 2, honestly. So we will start that maybe around 1 p.m. We can take a short break now, right? Yeah, so thank you everyone for attending the first session. Let's reconvene in the next 15 minutes. Don't go anywhere. And when you look at my slide, think about how machine learning is being used in companies like Paystack or Pure Life, which I think they're doing a fantastic job, and which stages to use machine learning there. This is the collab we talked about. You can join the Google groups or look me up on LinkedIn. And please provide feedback for all of the sessions today. Okay. Thanks, everyone. See you in a bit.
Bedais. Bedais.
So
Okay, sorry, is it just me or we've lost her again? Can,
hi, is someone saying
can you-
something? Hello, Chris.
oh yeah, I was trying to check. I hope whether it was network or something,
We're
or you
still
were
we're
sure.
still here. We're still here. We will join. Femi will come back in about 15 minutes. Before like to start his class. So stay
Okay,
on the
okay, okay,
call. Okay.
okay. Thank you very much.
Femi, can you please join this Zoom? Femi, please join this Zoom so that
Yeah, thank you. I would need to put this because I'm a pastor in training. If you see the churches in Europe, you probably want to be a pastor. Those churches are beautiful now. We wish you yeah, the same. Just want to see MS, bro. No, it's not close. It's not close, bro. Church is very fine. It's not close. He just asked the ball. Some were embellished. They spent money on them. A lot of money. Try, but maybe outside. I think so. I want to mirror my display. I can see. Yeah. Okay. The mirror. Oh, okay. I'm coming. I just need to. My Photoshop popped up. Okay. And so look it. Oh yeah, I'll start seeing my vanities. I'm so vain these days. Did you? I'm not sure it's from. It was connected before. Now it's going to be shaken. Is it connected? It's not connected. It's not. Let's use my. Oh. I know. So it was fine. Yeah. All right. No, actually, it's fine. That's fine. HMI 2 received that. I don't think he's shaking you. He's shaking. What? He's trying. Oh, stop this one here. I think it's important. Oh, c'est pas long. Okay, work sign. Template passcode. What is this? That's not necessary. I'm not doing that break. Okay. Let me share my screen on Zoom. Okay. Can someone confirm online on Zoom? Let me confirm. Okay. Okay. Hello everyone. Sorry, let me minimize this guy. Actually, bring it back to this. Hello everyone. My name is Oluwafemi Aziz. I'm co-founder of AI Saturdays Lagos. I'm also head of data science at Pastel Africa. Pastel, I think, okay, I'm not muted. At Pastel, we do enterprise AI for companies. We build like AI products and services usually for companies. We build all sorts of models, like all sorts of interesting models. And one of our most popular applications are in finance. So we've been partnering with lots of fintechs and banks, and we have products that they actually use. So we have products that are live. So I have experience with going through the process of having to build an AI application, thinking about where to get your data, thinking about how to solve your data problems. And you have various kinds of data problems, and I'm going to talk about it on one of my slides. But an AI application lives and die by the quality of data, right? If you're building or prototyping a mobile app or a web app, I think you start from functionalities, right? You know what the app wants to do, and you start to build your app, and it's pretty exact. But when it comes to AI, because it's AI, you need data. And so your first set of problems are very data related. In fact, like your largest set of problems are data related. You'd wish you had a data set that was in a certain way that was so good that you can build a model, but sometimes you don't have that kind of data sets. And so me actually being in the field means that I fight with these kind of problems like every day. So I'm supposed to teach you ways to move around that data problem, right? Basically. So I call this prototyping. And the reason why I call this prototyping is because unlike other fields, in other fields you can easily have an idea and you can build it out very fast. You can have your initial version, something to try. But when it comes to AI, in the past, it was hard to prototype any AI thing. It was hard. You had to have the data. The data is not good. If it's not quality, you can't build anything. But these days, because of generative AI, you actually can now prototype AI applications. You can build something, even though it doesn't work as good as when you have your full data sets, right? So having the full good data set is not always, it's a luxury. Sometimes you need to spend money on it. But I realized that these days you need to have a way to be able to prototype an app and then maybe show it to an investor or to someone who wants to invest in you getting quality data sets. So this is, it's good that we can do that now because of generative AI, the growth that we have in generative AI these days. So we're going to learn how to use all of those tools very well. Okay, what am I going to talk about today? We're going to start by visualizing an end product. So we're going to walk through a sample app that we want to prototype. We're We're going to talk about how to go from idea to products. How do we prototype fast? From the ideas products, we will learn how to prototype fast. How do you synthetically generate data sets? How do you source your data? How do you label your data? How do you explore your data? Tools for doing all of this. How to do data cleaning. In our unique case, we have class imbalance. So we're going to talk about how to handle class imbalance. It might be a bit extra, with some extra maths. We're going to talk about how to do modeling, how to tune hyperparameters, model explanation, model monitoring, and then we would look through the final products and then take questions and answers. You would notice I didn't talk about model deployment because in prototyping, there's a way to kind of deploy our app in prototyping. That's not like the rigorous model deployment thing that you would do if you had a full project. And oftentimes, I don't worry too much about model deployment because there's a new field called MLOps these days. And people that learn MLOps usually would know how to deploy models very well. And sometimes some people used to have a team where there's an MLOps expert. And sometimes you need to have basic MLOps skills. And there are also some advanced tools that kind of help you escape having to do MLOps or having to do extensive MLOps these days. So you can get away with having a live product without doing rigorous MLOps. Even though if you know how to do MLOps, you can save money and probably deploy that model in a cheaper way. But these days, there's a way to at least deploy a model. So if you have a startup today and you want to have your AI product live, you can have it today without knowing MLOps. But if you want it cheaper, you probably might do MLOps. So I'm not going to be talking about MLOps directly, but I'll talk about tools that can allow you to do that. So in preparation, I have the slides. If you want to get to the slide, scan this. If you can scan it, or go to prototype Bitly prototype AI presentations. Sorry, guys. I was just catching up on the chat. So the presentation is here. Everyone gotten it, right? Yeah. Hopefully everyone online.
Just give me 30 seconds, please.
30 seconds. Your time starts now.
Yes, okay, fair enough. Okay, yeah, I've got it. Thank you.
Yeah. Okay, I guess that's the slowest person we have in the class. So we can move on, right? Okay, now the next slide is we have a code that we're working through, a presentation code that we're working through. So I need to open the code myself. Okay, we also have a presentation code. So your presentation code. So there's a code to walk through for this presentation. So you can get that from this Bitly prototype AI. What just happened? Okay, yeah. So we have a presentation code too. Can we move on? Or do you need 30 seconds too? Yeah, that's the standard timing now, 30 seconds. So I'm going to be switching from my slide to the code, my slide to the code and all that. Everyone good? Everyone has the slide. So actually, if you have access to the slide, then you can scroll to this page to get access to the code. So I wouldn't waste time on this. The code will take you to GitHub, and then you can pull the code from GitHub, and then you're going to have this same thing that I want. Let me change the view to Zen mode. Yeah. Okay, everyone can see the code, right? No,
Yes, you can.
Okay. So let's move on. First thing, let's visualize the end product, right? Is my code live? My code is not live, so I need to install my libraries. These are the libraries we're going to be using. One of them is, okay. So I need to install my library. Most of my requirements are probably already satisfied.
I don't see code on top of. I'm not seeing code.
So I'm installing my libraries. Yeah, question?
I can't see it.
You can see it.
Yeah, but I've got it to do.
GitHub. And you didn't see it on GitHub.
So how should I get this to? You have to download it.
Your folder, because there's a file there that you're going to reach from. To clone the whole folder, you need the whole folder. File in it. You don't need. I think you can just. You don't need to know how to give clone. You can just you can just do. There's this thing on top. You can just do clone and you can download it as a zip file. It's not. It's. I mean, no. So you can, guys. Depends on the kind of student you are. If you like to mess around while the class is going on, you can have it set up on your computer. But if you don't want to do that, you can always like access the code in the past. But it would be nice for you to at least be messing around. If I try something, you can tell me I'm lying, that it doesn't work, or something like that, you know. So yeah, let me import the libraries. Don't worry about each of the libraries. I'll be introducing the libraries. That's what the session is about. I'll be introducing the libraries along the way. So let me import all the libraries. Okay, libraries imported. So let's just a bit about our end products. What are we trying to build? So I'm trying to build a very simple app, a very simple AI app. What this app is supposed to do is that if you give me 3 variables and I plug it into this model, I can use those 3 variables to determine whether a client is going to default on a loan or not. So it's a loan default model. So if you give me bank balance or someone's bank balance, their annual salary, and whether they are employed or not. If I have those 3 variables, I can use that to determine if the person is going to default on a loan or not. Some of you might have questions that, is that enough? The purpose of this demo is not to be exact with the modeling. It's not to have AI accurate model, right? So this is not going to be very accurate. You shouldn't be accurately able to determine if that is true. From this is very few data, right? But for the simplicity of the demo, we're sticking to just those 3 variables for the simplicity of the demo, right? So you're not going to see me with very high accuracy scores because you need more data than this. You need more than this, but for the simplicity of the demo. So it's a simple app. Huh? Yeah, it's a simple app. Give me a client's bank balance, their annual salary, and the fact that they are employed or not. Give me those 3 variables, and I want a model that can predict whether the client is going to default or not. So our first tool, let's visualize our end product. Our first tool is called Gradio. I don't know if I should introduce Gradio here, but it's a very nice tool. What Gradio does for you is that Gradio allows you to have a user interface right on your IPython notebook. This is sweet for demos as a data scientist. Because for you to be able to do this, let me tell you what the hurdles you've crossed. You've crossed the hurdle of doing a back-end server and doing a front-end HTML, CSS, JavaScript to have this interaction.
So instead of having to do all of those auto, which a data scientist doesn't really care about, and you want to do demos, you don't want to show your demo in like your IPython notebook all the time. How many of you always have to do that? You have to show your demos in IPython notebooks. You want to talk to stakeholders and you want to show them something they can interact with, right? And you don't want to have all those skill sets. I do have all those skill sets. I can do all of those things, but I'll tell you, it seems to be one of my most useless set of skills. I don't use it. I don't have to. I don't use it again, but I can do it, but I don't do it. And I can do it because of I've had history of like doing like this is the different part of software development over the years. But I don't need the skill set. I even know how to build mobile apps, but I can't remember the last time I built a mobile app because I don't need to again. But with this tool, you can get your bank balance, annual salary, and it's very easy. Look at so the nice feature about Gradio is that it's very easy to code. Look at, you just need an interface. You need to supply a function. That function takes in 3 parameters, right? Right now there's no model, right? But the goal is to fill this part, to put the model there, right? Train the model and put it there. Right now there's no model. So given these 3 parameters, and what do you do over here? You define the input type of the 3 parameters. Text. That means bank balance is going to be text. Annual salary is going to be text. And then there will be employee is going to be a drop down. And the choice is yes or no. Easy. And your output is also going to be a text. So using the interface, you just define the interface type. And then you launch. And then you have this thing called share equals to true. Now, the nice thing about share equals to true is that it gives you a public URL that everyone can actually go to and operate your app for 72 hours. Do you know how cool that is? You don't have a server. You don't have a UI. You just have something you built on your code, and it packages all the things you need for that code and deploys it for you. For 72 hours, you're not paid yet. You're not paying anything. You don't need to pay. It's free. It's open source. And for 72 hours, I can share this code with you. It's live. It's public. You can access this code, and I can interact with the app on the website. That's how cool the tool is. And this is what this presentation is about. Cool tools. That's what we are doing. We are doing cool tools to solve your problems. So this is a practical tool for data science. So what can you do? You can put a bank balance, let's say 2,000, annual salary of 5,000. I don't know who collects that low. And then obviously you have to, if you have a salary, you're probably employed. But maybe some people have salaries that when they're not employed or something. But and then you submit, and obviously we say no model yet. So the goal of this presentation is for us to build that model and have it live that way. So is this exciting already? Yeah. Okay. Enough talking. Let's start building. Where's my slide? Where's my slide going to? Okay, my slide is right here. I want my slide back. Okay. I want my slide beside my code. Okay. Let's talk. So that's Gradio. That's the first tool of the day. Very useful tool. And we can already see how cool the tool is. What's the question?
It's you also do like you use image.
Yes, I'm sure you can. Yeah, I'm sure you can. Yeah, you can do image. So, yeah. Someone is asking me if I worked on it. I did not work on it. So I'm not one of these developers. I don't even contribute to it. Yeah. There were days I used to do more open source, but no. Did you remember that day, one time when we had a partnership with Pandas and we were all doing open source contribution to Pandas? We once had the time where we were doing open source contributions. Maybe we'll do one of those again. So now, how do you turn an ML idea to a product? So you have to ask some questions. And the questions, my theory is that you guys that ever have any ML idea, you're stuck somewhere here. And I'm supposed to teach you a tool that helps you get unstuck. So this is my theory. If you ever want to build an ML product, you're stuck somewhere here. And I'm introducing you to tools to get you unstuck at every point in time, right? So when you have an ML idea, I have this cool idea. I want to build an app that if I want to predict this thing, can predict it and all that, something like that. The first thing is, can you code your ML idea? If you can't code it straight away, you can use a tool to prototype with generative AI. So you can actually prototype your whole idea straight away, which is one of the first things we're going to do. We're going to prototype very fast. You can prototype fast. Like before you get any data, before you know what you're doing, you can now use generative AI to prototype very fast. I'm going to introduce a tool for that. Now, if you can actually code, the next thing you want to ask is, do I have data? Do you have data? Now, if you have data, so if you don't have a data, you have to source for your data. Can you source data? And we're going to talk about data sourcing. Where do you go look for data? Now, if you actually have data, the next question will be, is the data labeled? But if you can source your data, then you ask the same question, is data labeled? Sometimes some source data are labeled, some are not labeled. But if you can't source your data, if you check all the places where online you should check for your data, then you want to consider synthetically generating data sets. You can synthetically generate your data. I'm going to teach you a tool that allows you to synthetically generate data. Now, if you do have your data, and you can source your data, the next question will be that, is your data labeled? If your data is not labeled, I will introduce you to a tool that allows you to label data. There's an expensive way of labeling data. I will talk about an inexpensive way of labeling data using generative AI and RAG. And another alternative could be, you could consider building an unsupervised model if you do not have a labeled data, right? But in most cases, you don't want to build an unsupervised model. You want to build a supervised model, especially if you can get labeling. So you can either label the data or build an unsupervised model. And yes, you have an idea, you have a data, your data is labeled. What are you waiting for? Build your supervised model. Someone could be like, yeah, but the idea is not ready yet. But I think for most of us, once we have our labeled data, the next things are like easy peasy, straightforward. Life is easy. Do you get, when you talk to a data scientist and you have an idea and you say you have labeled data, they'll tell you to just sit back and relax. It's easy. Modeling is not that difficult. At least from the programming perspective, like 80% of our problems are usually right here. Right?
Yeah, question.
Yeah, let me see. Yes, Gradio can run in a Jupyter notebook, whoever is asking the question. Okay, who is raising their hand? Can you talk? Okay, same person. Oh, so right now, just to answer the first question, this is Gradio right here. We actually ran it in a notebook, and you can see the interface is sitting right here on the notebook. So yes, it runs in a Jupyter notebook. It's that cool. Yeah. So, yeah. It's that cool. So the same thing I did, I can operate the same. The way I went to that website that I shared with you guys. Oh, by the way, it's also on your local host. So you can also go to your local host. So I can do the same on notebook right here. I don't need to go anywhere. Yeah, same thing, output. Yeah. Okay. Let's proceed. Prototyping. Prototype fast. Yeah, the whole project is prototyping, but you can do your very initial fast one. The fast one is easy. Easy. The first one is easy. There's a tool called Kill N, or whatever way they call this tool. It allows you to build AI products using generative AI. I like to use the word prototype because it doesn't mean it's going to be effective, right? But it can allow, it can be good to an extent, and it can allow you to do a demo, which is what you usually want to do. You just want to do a demo. So you can build with Kiln or Kiln. I should learn how to pronounce their products. But basically, what is product Kiln or Kin? What this product allows you to do is that it gives you an interface. They're even so cool. They allow you, you can start it or you can download like a local app for it, even though the local app opens a website. Do you understand? So they make it very easy. You have to install an app for it, but the app basically just opens a website. That's all it does. So let's go play with Kiln. I have somewhere to play with it right here. Okay. So let's go play with Kiln. All these things are just getting in my way. I think I had it opened. Yeah, I had it open some. Yeah, I had it open here. Okay. So, surprise, I already started an app on Kiln. But the way the app works is that, so it's the same app we're building, right? And so these are first step in building our app. The first thing you want to try. This one, you don't know how to code. You want to use a tool. So in Kiln, you can do something called, you can start a project or you can start a task. Is there a way to? So I started a project called Finance AI. Another project, I started a task. I can start a new task just to demo to you guys. So you can start a new task. The way it works is that you're supposed to, okay, instead of starting a new task, let me duplicate an existing task so that it's going to be easy. Let me duplicate an existing task. Okay, let me just edit the current task. So the way it works is that you obviously give a task name, and then you give a task description. What do you want your AI like application to be? So what I'm saying is that I'm telling you that predictive a user would default on their loan and provide the output in the following format, right? I told you just tell me default and predict a user's loan defaults. In English language in text, you can describe what the task is. You can, so this is for the computer. They'll tell you what's for the computer and what's for you. You can describe it by, you can do a task description for you and your team. And you can give it a thinking instruction. This thinking instruction is for models that think prior to predicting. So models think prior to predicting, and you can give it a thinking task. And then you can add a requirement to it. The requirement is you can add an input schema where you can define your inputs. So I want employed, it's a Boolean. And the question is the user employed? This is the description. I want bank balance, is a number, is the user's bank balance. I want all of these. And then I require all of them. And then I tell it to give me an output. The output is called defaults. Just users loan default outputs. And then just like that, by describing the task, describing the inputs, and describing the outputs, you can have an AI app working straight away. And so let's play with the app. So let's play with the app. So now with this app, and so after creating the task, you can generate synthetic data for the task. So another thing you can do is after you create the task, you can generate synthetic data for the task. So the model is going to, so using generative AI to generate synthetic data to train a hypothetical model, you're doing everything on the platform. So you can generate a synthetic data, you can add, the beauty of the synthetic data is that, the beauty of the synthetic data is that, so I'm telling you to generate 8 samples, is that you can even add your own like samples of data to it, for example, and then you can use that sample of data to generate more data sets and all that. Look at the synthetic data I generated. For example, this person is employed, the bank that, so can you see it creates sample of data of things that you could have to deal with, right? And you can save all the data. I hope I don't have any error. And you can use a zero-shot method. You can provide, usually you provide an OpenAI key. If you have an OpenAI key, you can use all different kind of like AI data. You can use Llama, you can use OpenAI. You have different prompt methods, few shot example, many shot example, chain of thoughts, different kind of LLM methods. And then you can run and save. Okay. it saved 8 new items. So let's go to the data set tab. So you can see these are different training data, right? When it generates all the synthetic data, it showed you, for example, it says this person is going to default. This other person is going to default. It shows you who is going to default and who is not going to default. You can look at, sorry, you can look at who is going to default. So let me move all this. So you can look at all these defaults. I think you can edit some of the data sets. Yeah, you can edit the data sets. I think it should be able to. Yeah. You can delete. Sorry, I think you can delete. If the data set is not good, you can delete. You can look at all of them one by one. They don't allow edits here. So you can look through the data sets and change and delete the ones that you think are wrong and not correct. But yeah, that's your data set for you. And so the model is trained. The model is trained using these synthetic data sets, and then you can try. So say if someone is employed, they are earning. Sorry. Let me say if someone is not employed. Let me say no here. Oh, sorry. This one requires true or false. So I'm going to say false here. False. They are not employed. I will take an extreme example so you guys can intuitively guess what the answer is. If the balance is like 500, I don't care about the money, the currency, and the annual salary is 0. Do you think this person will default or not?
Yes.
Yeah. Okay.
Default.
True. Yes. Yeah. Okay. 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 Oh no, that's what I'm saying. You need more features to be certainly sure. This is a demo app. We're keeping it simple. I don't want to start filling a long form just to demonstrate something, to keep the class very simple. So it's a demo class. I think I have some more chairs. I think there's some more chairs over there. It's a demo app, so I don't want to start feeling like a very long form. You need more information to be sure that the person is going to default. I need something simple and intuitive to explain to you guys. Yeah. So let's and that's the thing. The point of this is the prototype, right? So let's create another intuitive stuff. Let's play with this a bit. Let's say okay, it's true. It's still gonna default, I think. Yeah. But let's boost this annual salary to say 1,000. It's going to default. It probably needs more annual salary. Let's give him more money. Let's make him rich. I think if he's employed and he has a lot more money, then most likely he's not going to default. And correct, yeah, it's not defaulting. So this is just, you can already see, you can build a very simple prototype using just generative AI. This platform is backed by generative AI, right? And it's also a free platform. The only thing is that you pay for your OpenAI SDK or whichever one you want to use. You can use open source ones, so you can still be fine. Let's go back to our slides. Yeah, so that's Kiln. You can already you can already see how to have your first tools that can allow you to do that. Now let's talk about synthetic data generation too. Synthetic data generation using generative AI. This is another tool called Gretel AI. Let me see, do we have chats? There's a question that is it from the code it denotes Boolean and the number logic or the app? It's on the app. I think for this particular app, you do everything on the app. We're not writing anything from code here. Remember, this is how to prototype when you don't want to code. So you're not coding, you're just prototyping, you're just playing with it. Or you're prototyping with it. This is Gretel. I thought I'm signing. What's the question? Is it? Oh, image, yeah. You probably can, it's generative AI, so you can imagine. It probably is just text for now. Oh yeah, someone asked the limitation of Kiln. It's generative data, so it's probably just text. I'm sure there's an equivalent one for images too, because generative AI works for text and images too. So I'm sure there's the same stuff for image. Now, Gretel, this is another tool for synthetically generating data sets. So that other platform was for using generative AI to build the whole app. Like this is, you don't want to code anything, you just want to have something. Someone, eh? You what? Yeah, vibe coding, yeah. Whatever the cool kids call it these days. Yeah. Okay, yeah. But that's the, you guys get the idea, right? I mean, I like it. Like we're very intelligent beings. We want to be doing things that are much more creative at the higher level. We don't want to be, if I have an idea, I want to see it come to life. I don't want to be going through the, defining variables and writing lines of code. Who wants to do that? Yeah, but you might have sleepless nights on whatever it gives to you, you get it like that. Like, please, for example, please don't deploy this for a startup. It's a prototype. So your company can tell you to build something, and this is what you deploy. Like you can see it does. You can see I tried the extreme examples. It did them very well, but in real life, things are not spelled out. Like an human being can do this. I don't need. That's why I showed you examples of what an human being can do. So the model can do this, but like the view in real life, it's a bit more. There's more finesse to how you set up your threshold, to who's going to default, who's not going to default. There's also bias. So be careful about what variables you're using and all that, and ensuring that you're not biased when you're giving loans to and all of that. There's so many issues in real life. So this is just a prototype, right? This is the laziest thing you can ever do. Do you understand? But I wouldn't build a startup of that. I wouldn't do it. Some people can do it. I think people are doing it these days. I wouldn't do it. Yeah. So let's do this. So this one, I'm thinking I might have to type this guy. Or let me get off this and copy this prompt. So this one is very interesting. This one you can give it a prompt, and then you can put a prompt there. So this is a nice thing that this guy can do. This is going to be effective this way. You just give it a prompt. It says create a default prediction app with the following columns: employee, bank balance, annual salary, and defaulted. This prompt is going to allow it create a data set that fits that prompt, right? And so it's a data generating platform using generative AI. And it's creating a decent data set. And you guys can see the logic here, right? It's kind of very simple, but it creates it, and it also uses the finesse. What do I mean by the finesse? Like, look at this guy. This guy has 10,000, 50,000 annual bank balance. He has a high bank balance, annual salary. It's not going to default, but this guy has a low bank balance. Even though his salary is still decently high, he thinks he's going to default. This other guy is as good. Then this guy, you start to kind of find some questions. Okay, why is this guy, start look through your data set. As I said, this is just a demo. Yeah? Default means they're not going to pay back. Oh, sorry. I should define my text. Yeah, the fact that I'm not going to pay back. Yeah. So to make this even more effective, you can do something interesting. You can actually add examples to improve your results. Cool, right? You have a question? Yeah, so you can even do something nicer. You can give it examples. Let's say you have some of the data, or you can create some human reasonable data set. So this is the nice thing about generative AI. Generative AI can not only like generate something for you from scratch, it actually can do well when you have samples. So let's say you have I'm sure some of you can sit down and write up some lines of this data yourself. You can do 5 lines, 10 lines, and the way you want to do it is that there's no whiteboard here. You can like draw a graph of like, let me see. No, don't worry about the whiteboard. Yeah, you can draw a graph of, say, okay, what are the scenarios I could have? So you can create samples of the different kind of scenarios and provide an example to the generative AI model, and it's going to give you a richer data set. So you could look at, okay, someone, how about some people are employed, how about people that have a high bank balance and high annual salary, or they're employed, low bank balance, high annual salary. Do you understand? So you create samples from each of those scenarios, right? Another sample is that, yeah.
Can this solve that problem?
What's the problem? Yeah.
IoT devices.
Okay.
Want to be able to track and monitor their privacy needs
Okay.
from IoT devices. Now the problem with this is that IoT device,
yes,
generating data,
yes,
now to like tap into the network,
yeah,
web packet and all that.
yeah.
How do I use this now to create such? Because, for example, things like emails,
yeah,
notification,
yeah,
you don't want it to be
okay,
just not from normal data, not personal data. So how can this generate synthetic data without me going to buy out one housing device and start creating my own?
Yeah. So I like what you're saying. It makes sense. So if you're going to create a prompt, your prompt has to be better descriptive, like a better descriptive prompt.
So it's based on the prompt.
You can create a good prompt, and then to even make it better, you can try to generate some examples on your own. Like try to create some examples that look like what you'll be looking for, some representation of different dimensions of the data sets. Do you get? So in this case, for example, I'm thinking of a bank balance that things by common sense would flag positive or negative. Like labeled data example you can think of. If you can give some of those examples here, it's going to improve how good your generative model is, because your generative model is going to be using that as an initial setting. And the idea of prototyping is that you want to add something that can work and you can demo to someone who could sponsor your project and maybe say, oh, this is good. And then you tell them that, oh, if you actually have richer data sets, this can be better. And then they can like put more money there. Do you get? So you wouldn't be that data scientist that just goes, oh guys, I have this idea. If only we have data, our model, it works. We just need data. You can now prototype. You don't have to wait for data. You can play around, create some samples. You can work hard on this supporting example portion. You can work really hard at it. You can really, really try hard. You can maybe find a cheaper version or something that could give you some data, something inexpensive way of generating something, because hardware is expensive, right? Therefore, inexpensive way of like generating sample data set. You get examples here. This can even be better. Like you can get better. Yeah. Okay. Yeah. Ethical considerations. I think you can create a private account. You can some of it has licensing. They have some security. They have an API key, so there's some security around it. I think yeah. You said what? Yeah, that's a privacy expert in the house. Sorry. Can you be loud? You're an expert at this. I don't know shit about it. Yeah, talk loud.
So I said sometimes it's because you're telling them to put some white line to keep the picture privacy.
Oh, under.
So it's also regard. So what DP does is that it tells you the average guarantee which someone can, your data, you can say that your data is going to give you a guarantee on average case. And what you want to do is you want to get that guarantee without having to add a lot of noise. So it's the process of adding lots of data, but control and optimize it. Yeah. They try to train that paper from what I know, like the research is very hard. And so sometimes it's just learning on all the different class data and trying to synthesize it once yeah, with some factor for sure.
Okay. It's on me, not
Yeah, that's no. And we've also done a differential privacy. Check me for it is hard. Differential privacy is hard. Yeah. Yeah. Differential privacy is hard. I don't know why Teju chose a career in that stuff. We suffered so much. I didn't know why she's going there again. I didn't want to see anyone more line of code from that thing. Okay, so that's Gretel. That's Gretel for you. Synthetic data generation. So this solves a lot of your problem, right? You already have a tool you can use to prototype your own stuff. You have tool you can use to generate your data. I feel like I put the cart before the horse. I should have actually talked about data sourcing first before synthetic data generation, but it doesn't matter. You might want to prototype with whatever you can synthetically generate first. And after you're done, you now want to start sourcing your data. Now, these are good places you would go to look for data. Kaggle is a good source. Then there's lots of data in Kaggle. Even this sample data I'm talking to you guys about is from Kaggle. I'll tell you what I did. I just woke up one morning and I'm like, I need a known default app data, and I need one that doesn't have a lot of features. And I searched on Kaggle, and I found this one on Kaggle, right? So you can get things on Kaggle, a lot of them. World Bank Microdata is a very good one. So open data on AWS. I think this, I'm not sure if a lot of people know this. This one, I just discovered this. They have lots of data too. You can look around for any data that looks like what you want. It adds to source data. Or in the case of hardware, like Simon's case, you might need to generate data sets yourself. Yeah. Someone says UCI repository. There's UCI repository. There's a lot of good ones. Yeah. I just showed you a few ones. There's a lot more. So data sourcing, and also this might also be the most expensive part of your projects. This is where some data scientists spend a lot of money. Some people, this is exactly where their research sits at. One of our projects, Teju, I think, what's it? Serene app projects. We actually have the project in AI Saturdays where we had an app. We built a mobile app to. Please, no. I'm not talking about Insta network. I'm talking about our food detection app. Don't mix it up. Eh? No, I'm not talking about differential privacy. ChildNet, yeah. So, yeah, the other one is a differential privacy project. That one is the company's stuff. I'm not talking about that. I'm talking about ChildNet. ChildNet is like, so we basically wanted to, during the early days of AI, where the word generative AI was not this good, and we couldn't prototype well like this, we wanted to have an app that you can take a picture of an African food, and you can know like what it contains and all of that. And piece out the nutritional content of the food and all of that. And we just noticed that there's no good data set to do that. So it was a data sourcing project. And what we were doing is that we started building a mobile app that can allow us to take pictures, and then we outsourced it. So we made it open for everyone to have the app and take pictures. So we had a big class like this, and we gave everybody access to the app so that people can take pictures. Like we're like, just anytime you eat at home, just take a picture. Yeah. So we told them snap before you eat. So we just tell them like, hey guys, when you go home today, just take a picture of your food, label, tell us what the food contains and all that. And that was like a data sourcing project. Yeah. Yes, question.
Yeah, my question. If you are building
AI application.
Okay.
And your data, you're kind of getting is controlled by AI.
Okay.
And your data is more like you want it to be written in a way that it's not going to be more than as a issue. Having a broader
Context.
sense.
Okay.
Okay. And I know people in the process of how OpenAI will make sure that it's what you put into
That it's
is what is providing. And also, even if you want to get a kind of limit, is there a way to put a kind of parameter
on like
OpenAI and say, these are what I want because of
okay.
this age.
Okay.
Age preference.
Okay.
For that.
Okay. The question you are asking now is she's asking I'm repeating for online audience. She's asking whether you can put in summary whether you can put context. I think that's what you want. Context to the question you're asking OpenAI. That's a generative AI question. Whether you can put context. Yes, you can put context. We're going to talk about it at some point. It's called RAG, retrieval augmented I think it's retrieval augmented generative AI or something like that. Generation, yeah. So you can actually contextualize your generative AI system. You can contextualize it. You can only make it ask questions that are specific to your own data sets, right? And we're going to talk about it. Let me see very soon. Yeah. We'll talk about it very soon. But I don't want to repeat when I'm talking about it. So yeah.
If you're working on a project and get this open source, if you're working on a project and you want to say, okay, because you want more data, just like say in child
Net, yeah.
You want to come in to be able to put their data, okay?
Yeah.
I want to people everywhere, you don't know where they're coming from.
Yeah.
You don't know if wants to be a hacker, you don't even know
Oh, I see.
are you able to at the end probably you want to now say, I don't want. It's not like OpenAI.
On to limit, yeah.
Like, okay, we are done with the open source.
Oh, okay. Yeah. It's easy. Like you have control. So now you're asking about security, right? Yes. So it's not really a data science problem. It's a problem with maybe the way I built the app and the way I built the server for collecting the data and all that. So that's the problem there. So if I built my app in a way that I didn't add enough security, I allow somebody else to start hacking my app, that's a mobile app security issue or a server security issue for collecting my data, right? So you have to do data quality. Somebody actually checks. Yeah. Yes.
They actually start down remove the data that is maybe it's too clogged or like it's internet or like you can we then so undertake this one by one so because it will kind of object detection and then start down your boundary works. Nowadays maybe you have a generative AI tools that
can help you at least get objects. Yeah.
Exactly. So you can pull it together. But before then, more to sit down and everything. The same with our other projects, which was
Language, accents, translation.
Accents,
Accent
as well.
Sound.
We have an app still online. You can speak to it. When we say looking at the mobile one, it's too close to the microphone, then you're writing down and trying to start to be on fighting. And then like that one was like because we already understand this by collecting each accent itself identification. So see when you're around or sign up people, then
so yes, basically data sourcing is hard, guys. Data sourcing is hard work, right? It is hard work. It's not fun work. It's very hard work. None of us would like to do it. But what you can do with the data as the fun part. But the data sourcing itself is a lot of hard work, right? Okay. Yes, you still need to clean the data, need to ensure that everything is fine. Yeah. So let's move on. Now, data labeling, yes, this is the point where I'll talk about your RAG situation. Data labeling is you can use Label Studio. So there's the manual one. Label Studio is a good tool. It's an online platform that makes it convenient. That makes it very convenient. I think it's sorry. Can we reduce the ACs? The AC is killing some people. Oh, is it the fan, not the AC? Is the AC? Both of them. I'm going to, because of time, I'm going to skip label data studio or something. The reason I'm going to skip it is very easy tool to use. What it just does is that it just gives you a user interface. Or do I have it on my code? No, I don't have it on my code. It just gives you a user interface that allows you to, like, it gives you all the tools you need to start labeling your data in case you want to label your data yourself. So you have a tool that can allow you to start touching this, labeling it, and all that. It's the hard part because if you have 200,000 data sets, you have to go through the 200,000 data set and label it. Yeah, it's the hard part. That's why I said it's the hard part, is the expensive part. You can also use so you can also pay people to label data for you online. Oh, by the way, yes. So you also give the tool to allow you to pay people to label for you online. So this one is going to be, let's say this is an option you have. Let's say you have a lot of money and you're a startup, they give you a lot of money to do this, and you have money to do that. But the interesting one I want to talk about is actually a case study from Pastel. So I have a link to the case study if you want to go read more about the case study. So what did we do? We had to label a certain data set, and we wanted to use this route that allowed us. We use this platform called Datasaw. So Datasaw allows you to label a little portion of the data set. You don't have to label a lot. So just maybe a certain representation of the data set. And then you use RAG. RAG is what you are talking about now. RAG is a method that allows you to give your LLM contextual data, like a data for the LLM to restrict its reasoning with, right? I'm not going to talk about the full science of it, but the way it works is that it literally takes your data set and chunks it up to searchable pieces, right? So that when your LLM needs context, it can search within the searchable pieces. So your data becomes very searchable, something that your LLM can search through. So let's say you write an English word, you write something, instead of your LLM thinking about what that word means, your LLM is going to go to the contextual data set you wrote. They call it vectorization. So it's a fast search method that allows your LLM to use that knowledge source to look for a context that refers to what you're talking about, and then use that context to respond to you or to respond to the prompt you gave. Do you understand? So it's called RAG. And so we take some of the little data we labeled, use that as contextual data for our LLM using RAG. We take both the label and the unlabeled data as a context to our LLM. Then we now use this contextualized LLM and the labeled data that you have as examples also to let me finish up. So now label the remaining set of your data sets. Yeah.
What kind of task is that? Yes.
You said what?
Semi-supervised learning.
Yeah, it's semi-supervised learning. Yes. So this is a way of doing semi-supervised learning using generative AI, right? But you could do semi-supervised learning with other existing semi-supervised learning method. You could do active learning, right? Active learning allows you to train a model on the simple data you labeled, and then use that model to now make predictions on the remaining unlabeled data. And then the way it does the predictions is that it uses confidence. So it uses the confidence of its prediction to determine whether it's so sure of that labeling. And then for those ones it's so sure of the predictions, it adds them to the ones it has labeled, and then retrains the whole model again, and then repeats the process again. So there's lots of like existing semi-supervised learning method, but this is how to do it in the day of an age of generative AI. And this is what we did in Pastel. And we have like this case study posted with Datasaw AI. It's also a startup that provides tools for labeling data. These are real life situations, so I'm giving you real life problems that I faced. Yeah. So now let's move on. I need some speed. Data exploration. So now you have your data set, you have everything you need. Time to build your model, right? So now I'm talking about tools you need at this point. You solve the data problem, you either synthetically generated it, or you did all of this. Now you want to build your model. Everyone does data exploration. Usually when you want to do data exploration, you want to do the following thing. You want to get an overview of your data. What does the data look like? What is the descriptive statistics of your data? Like what's the size? How many data sets is it? How many columns do I have? What's the mean, median, mode? All of that fancy things. You guys know all those things you do, eh? You want to do that. You want to do univariate visualization and feature profiling. You now want to start to do like look at statistics of each of your variables one by one, you know, and you want to look at you want to profile each of those features, right? And then you want to do multivariate visualization and correlation analysis. Now you want to start looking at the relationship between each variable, right? So employed, what's the relationship between the employed variable and salary, right? Are they correlated or are they uncorrelated? Something like that. You want to look at the correlation of your variable with your target variable. You want to look at a graph of like your multi-variable. You want to do all of those interesting things. And there is pandas code for doing everything. How many of you do it? You do pandas to describe, do all of that one by one. So yeah, another cool tool. There's a cool tool that can allow you to, instead of doing all of that one at a time, you can simply import your data, read your data from your CSV, look at your data head. I mean, you don't need to do this. I just like doing this. It's habits. I want to drop this index because this index is, oops. This index is repeated. Just from looking at this guy is repeated. So I want to drop the index. By the way, dropping the index, I could do that later. I'm only doing it because I knew I had that there was an index column that I wasn't needing. So I used the tool. And now it's easy. You just import the tool is called wide data profiling. So you can read more about it. So wide data profiling. Now, what's the cool thing that this tool does? This tool, you just give this tool your data. I give it a title, and this tool automatically profiles your data for you and gives you this beautiful user interface. Can you guys see? Gives you this beautiful user interface that's an overview of that's a profile of your data set on your notebook. Right? So instead of like doing all those exploration code one at a time and all that, I mean, we want to do that, but no one has time for that. You just want something that has all of those exploration stuff at one spot. And you want to see it in a very nice, fancy way. This tool allows you to do that. Look at your data. You have your data set statistics. You have number of observation, the missing cells. You can see duplicate rows. You can see all this data straight away. And then you can see your variables. How many is categorical, how many is numerical. You can look at your columns. Our employee column is categorical. You can see that's the high color correlation. You can see it's distinct variables. There are 7,000 employed and 2,000 or 3,000 unemployed. You can see all those things. You can see your bank balance, just on one spot. And you can have an idea of some issues with your data set. You can see the histogram of your bank balance straight away. You can see your annual salary. You can see basic statistics of your annual salary. And you can also see like the histogram of it. Essentially, with your defaulted, you can see the statistics of it. Now, this is why we have an imbalance problem. You guys understand that? I said we're going to talk about to handle that. This is the imbalance problem. There's only 333 samples that are defaulted. Everybody else doesn't default because people rarely, default data set in this place is highly imbalanced. There are very few people that defaulted. I wanted to say people rarely default, but not necessarily the case. But in this data set, they rarely defaulted. Someone's going to shut me up immediately. But in this case, the data set is very highly imbalanced. And you can see some things like, you can see this graph that shows, this is the multivariate visualization, right? So annual salary bank balance. This tool allows you to play with what is x-axis and what is y-axis. So you can choose where x-axis, can see what y-axis is, and you can see the visualization. So this simplifies visualization for you. And then you can also see correlation variables, see variables that are very correlated, see correlation between all your variables, and look at all the correlation numbers. You can see missing value stuff. You can see samples of the data set. So you can see first row samples, and you can see last row samples. You can see samples of the data sets. This tool just makes data profiling sweet and easy. That's all about the tool. Sweet and easy. You have one tool that just saves you all those lines of codes. Yeah. Remember, it's for prototyping. I want to explore my data, but I don't want to start writing all that stuff. I need to see what's going on. If there's an issue, I need to know and move fast. All right. You might do a detailed analysis later. Some people might want to do much more detailed analysis. So you can still write code to your detailed analysis, but this allows you to see the data fast. Yeah, that's cool tool alert. Now let's talk about data cleaning. Apart from when you've explored your data, you want to clean your data. So you want to look for missing data. You want to detect anomalies or detect data drift or look for any issue your data might have. So I like this tool because this tool is called CleanLab. So the way CleanLab is built, there's a publication on it. So normally whenever we take our raw data, we do our data cleaning like before we even feed it to the model, right? So but what CleanLab does is that CleanLab goes through this approach where you have an initial model. So the goal of this initial model is not to make any good prediction. It's not a good model. But the initial model is what the raw data initial model is what is supplied to CleanLab. Do you understand? CleanLab then detects issues using that and then can give you the issues or can predict those issues and can let you know what the issues are. And then you can fix the issue, right? And then build a better model. This is their philosophy. You understand? This is why I like. This is a different approach. So I would clean data. I wouldn't ever have a model when I'm cleaning my data. So all you have to do is just put your model in a state that you can feed to a model. Put your data in a state that you can feed to a model. And what is that to most people? Change your categorical variables. If you have text categorical variables, change them to numbers. Simple. Don't do anything more. Just do that. And ensure that you fill in your missing data and all of that. Just do that. Once you do that, you can feed it to clean data. Because of time, I'm just going to show you how powerful it works. So in this case, these are the things I need to do, right? I need to do my X and my Y, separate my label from my variable. I need to split into train and test, right? And then I need to fit my model on the train. And then I need this probability prediction as an input to clean data. So the clean data model. And I think I jumped a bit here. And then, yeah, from clean data, I can import something called data lab. I provide my data. I give you my data label name, the name of the data label. And then I try to find the issues. Now, I give you the predictions of my model predictions right here. Remember, I call the model prediction on all my data sets, not train test and all that. I called on all my data sets. I trained on train, and I called it on all my data sets so that the size of my predict probability will match the size of my data set, right? And I give it that prediction probability, and I tell it to find issues and to report. That's all. Find issues and report. Very fast way, very cool tool for solving this problem of looking for issues in your data. And what does it do to you? It gives you a report, a detailed report of issues in your data right there in your notebook. So it tells you that, hey, I found outlier issues. I found out of distribution estimator issues. I found non-IID issues. I found class imbalance issues. We're aware of some of them. We know there's class imbalance. I expect there will be some outliers, but there are some new issues they also found. What's IID? IID is important because IID is like the assumptions we have for a machine learning model to work fine. So if there is an IID issue in my data, it means that those data sets, like, they don't follow those assumptions. Did you teach IID? Did you teach it?
No, but I have in the class.
Oh, you have pros in the class. So you're asking your pros because not everybody knows.
Okay. Something like that.
Yeah, people already Googled, by the way. People already Googled. Yeah. So basically, it just means the key assumption to your model. It means that your each row is a sample that stands alone, that contributes learning to your model, and not a sample that depends on another row in your data set, right? Because if it depends on another row in your data set, then it doesn't contribute learning to your model. It's not an independent sample. Do you understand? To your model. So each one has to be a sample that whatever process generated that sample, yeah? Multicollinearity. Maybe something like that, but like multicollinearity implies dependence, right? It does imply dependence, yeah. So the idea is that the thought pattern here is this. If there's a process there's a distribution that's generating samples for you, each sample has to be uniquely independent generation from that distribution that doesn't depend on another. So something that's probably not IID would be something like a sequential event. So let's say event B happens because event A happens. And so event B depends on event A. Do you understand? So why is that not good for your machine learning model? If event B depends on event A, then event B does not contribute any extra knowledge to your learning model. Do you understand? It's not a training data because it doesn't really train your model. Your model knows all the things it needs to know about event B because it saw event A. Do you understand what that means? Because the model has seen event A, it knows what's going to happen to event B. So if you add sequential events like that, you should use like a time series model. Do you understand? In that case, you use the time series model. But yeah, you have the idea assumptions. But yeah, this is not what this class is about. That's basics machine learning. But it just means every event should be independent enough, and that should be fine. So, and then it shows you the number of issues. Class imbalance, there's 333. So you guys remember when we saw the imbalance issues, right? That small class was 333 of them. So he found them as like, oh, this class is very small. Outlier issues is 112 outliers. There's label issues, the 3 label issues. The nice thing that CleanLab also does for you is that CleanLab could tell if the data set is probably not well labeled. If it's not reasonable, if it's figures that it's not well labeled, it could tell. So, like the other lady said, when we're labeling our data, if you have data quality issues in your labeling, let's say your labeling was not so good, you have data quality issues, it could actually help you out here. So you could look at those. The idea is that when you look at this label, you're supposed to look at that sample and see and look at it manually and see whether it makes sense. And you're supposed to help relabel it. And then just one non-IID issues. I think I would ignore that one non-IID issues. I don't know why it's I don't know what the algorithm does. And then it gives you detail of each class, each issue, class imbalance. It gives you the issue, it explains the issue in case you want to understand. It gives you examples of those who have the issues, right? And then it gives you the rarest class. Which class is the rare one? Outlier issues. It does the same thing for outlier. So that's what's cool about this tool. It just gives you those details. It's also a good learning tool because you'll get to understand what the issues mean. The label issues, it gives you explanation of the label. It's very nice reports. You can read through reports. Non-IID issues, you explain the violation of the IID assumption, as I just explained to you. He explains it over here. Issues like shift, drift, autocorrelation, and all that. And he looks at that specific violation and gives you the specific violation. Just one violation. And that's it. You can fix out those issues, you can get those issues out. You can look at those issues, get it out, and then you can do something about those issues. In my own case, I just ignored it and I moved on because of time. So you can fix those issues. But I think over here I showed you how you can drop the outliers. For example, instead of doing my outliers, I'm just dropping them. So another good thing you can do is if the data is not a lot, you can always drop it. So most people used to drop outliers sometimes. Sometimes that's what to do about the outlier. I'm doing the laziest thing here because it's prototyping. I'm prototyping and I'm working fast. So I'm doing the simplest, easiest things without thinking too much. So I'm dropping the outliers. And of course, when you drop your outliers, you have to see how that influences your how that influences your class imbalance issues, because you could be dropping your rarest class. You don't want to drop your rarest class. So careful with that. And then this is just code to find more of those issues. So that's what's nice about this tool called CleanLab. It's very, very useful tool. Let's talk about handling class imbalance. This is the part where I start to go a bit technical, but I think I'm a decent teacher. And I try to, if I show you equations, don't be afraid. Yeah, they're simple, they're very easy, they're not that hard. Don't be afraid. So one popular technique for handling class imbalance. So remember, I'm teaching you tools and techniques. So this part, I'm talking about the techniques, right? We've talked about tools and techniques. So there's a technique called SMOOTH for detecting class imbalance. So how does SMOOTH work? SMOOTH means, help me now. Someone knows. Google is helping people. Someone said small. Yeah. Okay. So what you're doing with SMOOTH is you're generating synthetic examples of the minority ones. So you're generating synthetic. So in this case, look at this graph I drew over here. Look at this graph. What this graph is saying is that, look at this graph. The green ones, the purple ones, it appears purple. The purple ones are random examples from minority classes, right? Sorry. Thank you. Let's be careful. This is actually, sorry, the purple one are actually, random example from minority classes, But then, now this is a synthetic example. Now, for you to generate, the idea is that what happens in the case of minority example is that, so imagine your data set. Your data set has variables, right? So each variable is like, so think about a simple graph like your X and Y axis, right? Think about a simple X and Y axis graph. X is like a variable and Y is another variable, right? Now, but usually you have more features. So you have more than one variable, right? So in case of X and Y, you have just two variables. If you have a third dimension, you have a third variable, right? Now, if you have 5 features, now you have 5 dimensions. You can't picture 5 dimensions. But the idea is that for every single row in your data, it's a point in the dimension of the features, right? So if you have X and Y, for example, and if the X value is 5 and the Y value is 6, that's a row of data. That's a point in that graph, right? If you have an higher dimension, there is like more points around. So each of your your row of your data set is like a point in a higher dimension of the features. And so this these points are like points in that higher dimension, right? And if you're imagining what is happening is that the samples of the minority samples, some of the minority samples are clustered in a certain area. They'll be in a certain area of that space, right? Some of them will be in a certain area. And so what you're looking at is that you're looking at the local area where N1, N2, N3, N4, and N5 are samples from the minority classes, right? And for those minority class, you want to generate a grain The green is synthetic data sets. Now, because the M1, so M1 is one random example from that. So for all of this, we choose one of them, right? Now, because this guy and this guy are both minority example, you can generate a synthetic data that's in between them. That's just right in between them. The probability that this synthetic data is also a minority class is high. Why? Because the neighbors are minority examples. So you're literally just going to the space of where the minority examples are, and you're generating more of them. You get, you're generating more of them. You're like multiplying them to fill up their local space. The logic is that in that space, that's where the minority ones are. So you are creating more samples in their local space by just shifting, by creating, looking at the spaces between them and controlling by this factor called A. Looking at spaces between them, you are creating new ones. That's exactly what Smooth is doing. I use mathematics. And that's the equation. So, is it a brilliant idea? Maybe. Was there a paper published on this? Yes. Are there probably more equations in the papers? Yes. But like, this is what is simply happening. Do you guys understand? And this is what you're required to know. For any data science interview I've seen, for you to use the tool, everything, this is all you're required to know. You don't even need to have read the paper. Most people I know haven't read the paper. This is what everybody mostly knows. Do you understand what that means? Yes, every complicated thing you know in data science has a simple version that makes sense. And sometimes, for you to practice, you need to understand those ones. You don't need to know everything. But if you do want to do a research in that area, if you do want to explore more, then you can find more. If you have time, if you're interested, if you like it, you can pick up the paper and read. So you can do more. But I'm just saying, for me to use it, this is all I need to know. For you to do an interview, for me to know whether you know what you're talking about, this is all you need to know. If you can explain this to me very well, I probably think you know Smooth. If you can use it and write an equation, I probably think you know Smooth. And how do you use it? Look at the code. The code is even simpler. You're just importing a library called Smooth, literally Smooth. That's the tool also. And then you just resample, fit resample, call fit resample on the data. Give it the train data, Y train, and call fit resample. And what you have here is a bigger set. So what I did is that I showed you the size of train. Look at the size before. One size for 8,000, right? After I applied Smooth, what's the size? 15,000. Smooth just generates more data sets. And if you look at the samples of those ones, you're going to see that, like you're going to see that there's a balanced size of variable there. So let's leave Smooth. Let's go to modeling. I'm going to rush through this. I'm attempting to explain a tool called XGBoost. And now to explain that tool has a lot of techniques. So I'm going to go through those techniques one by one, right? Tejo has done some of this, so I'm going to skip through very fast because she has explained it. Tejo has taught you what supervised learning is really about. Because what we are doing with supervised learning is that we have data sets, right? And we are trying to fit a line through it, right? Okay. We have data sets and we are trying to fit a line. Guys, let's focus. Your drinks, your snacks are coming. Just stay with me. Stay with me, right? Just look at me. Don't be distracted. So, and the way it works is that we have some parameters theta that we are trying to learn. I'm good. Yeah. We have some parameters that we're trying to learn. Kind of good. Thank you. So we have some parameters that we're trying to learn, and each of these parameters, anytime you see this y theta x, right? This y theta x is simple. It's simply a line trying to fit a data set. It's a function trying to fit a data set. The reason is because even though I have this example in my data set, I have this example in my data set, there could be a time someone could want me to make a prediction of an example that's not in my data set. So I'm trying to learn a function that gives me that prediction. Do you understand? But it's not in my data sets, right? So I'm trying to learn the spaces between these data sets. I'm trying to have a function that always maps this guy to this guy. That's what I'm trying to learn. And that's what like supervised learning is about. So the examples are the ones that are labeled already, and I'm trying to learn with them. So I also want to avoid this. The idea is that the way the model learns is that I make a sample prediction. I use a loss function. If I make an error, I use the loss function as a feedback to my system, and the model learns better. A common loss function is this guy, mean squared error. Please don't be scared about these equations. There's nothing special about them. Mean squared error just means the difference between my prediction and the labeled data. That difference, right? Square that difference. That's why you see the square. And then add it for everybody. So this, all the loss, add it together. And then you have one number. That's what it is. This big summation sign just means addition. It means add every sample of this one, right? It doesn't mean anything special, right? And then we have something called regularization. And we need to talk about regularization. Why is regularization important? You see, if you just use the loss function and you don't use the regularization, what your model tries to do is, your model tries to do this. Your model tries to fit a line that memorizes the data sets. Why is that wrong? You're going to have a very high accuracy on your training sets, but oftentimes when you check that model on your test sets, you would have a poor performance on your test sets. The reason is because your model is simply memorizing the data. Your model is just drawing a line through the data sets, and the line is drawing through the data set is not general enough to handle cases that are outside of your data sets. Do you understand? There are cases that are outside of the data set that model is not trying to generalize very well. So we call it a generalization error, a poorly generalized model. It has also, Lacram, Laporte, whatever kind of nicknames we could give to it. But let's move on, because I don't want to waste too much time on this. The other technique, so that's regularization. The other technique I want to talk about is decision trees ensembles. So a simple model, a kind of machine learning model that's very simple, is a tree model. How does the tree model work? The way the tree model works is that the tree model uses a logic to split your data sets and then assigns value to the different leaves of your data sets. So for example, I could have a model that looks at age, gender, occupation as an input. And I could say, oh, if your age is less than 20, you are belonging to this leaf. And if it's greater than 20, you're belonging to that leaf. And then I'll assign a value for each of the leaf you're in. So this one I could assign you -2, I could assign you -1. It's a very simple tree. The tree is just a simple logic that splits your data sets, right? That's what the tree is. Just a logic that splits your data sets. Do you get? I can come to this room and be like, how many of you, and it's practical, right? Imagine all of you are points data sets, right? And I say, how many of you are less than 19 years old? Some people will say, oh yeah, I am. And some people say no, right? I could split this class based on that logic. Do you get the idea? And I could say, if you're less than 19, this is your value. If you're more than 19, this is your value. Do you understand? That's what the decision tree is. It's simple like that. Now, instead of having one tree, you could have 2 trees. You could have 3 trees. You could have 4 trees. How does that work? One tree can split your data set in a certain way. Remember the tree? The tree is a model. The tree is a logic that splits your data set, right? You could have another tree that splits using another kind of logic. So one says age, do you use computers daily? Do you get? Now, you could notice that, notice this girl, right? This girl right here. The girl is less than 20, right? But she doesn't use her computer daily, so she's here. Do you get? For example, so one logic could put you in one class, one leaf. Another logic could put you in another leaf. So I'll use the second logic to put what? I will assign different values in that second logic. Now, how do I use the tree ensemble? So when I want to do the tree ensemble, when I want to ask a question about this particular girl, this girl here, one of them, sorry, I'm not trying to be, just look through the diagram. Look at the person I'm talking about. I'm talking about this first person, right? She's less than 20, so she has +2 as a value. And she uses her computer data, so she has +0.9 as a value. So she has 2.9. So you get the idea. So the ensemble is just a sum of all your leaf score, right? So we call it an ensemble. Ensemble simply means a combination of trees. Each tree is very small logic, but we can combine those trees together. Why is this combination important? You're going to see in the next slide. It's because this combination allows us to do what's called gradient boosting. And you guys are going to see how gradient boosting works. What gradient boosting does is it's a very simple algorithm. This is another technique. All of this is part of your XGBoost model. Trust me, when you're coding, it is very easy to code. I'm just explaining the intuition behind the model for you. So how does gradient boosting work? The way gradient boosting works is that you select an initial model. I already told you what a model is. A model is one tree. I split your data set with one logic. Simple. Think of a model like that. So let's say we have an initial model, say F0, right? The model could be like, hey, anybody less than 20, greater than. That's what the model is. Simple model. The model is going to give score to everybody, right? If I use the logic split the data set, that means the model will give score to everybody, right? Now, the score is going to be wrong because the model is not going to be correct. So there's going to be something called residual, which is the difference between the actual score that a row of data should have and what the model gave it as a result. It's called the residual or loss. Residual is another word for loss. Three people just like residual. They use residual or loss. And then what you do is that the residual becomes the new data set, right? Now you now use the residual to create a new model called H1. Use the residual to create a new model called H1. H1 is another tree. Remember I said ensemble of trees, combination of trees. Use that this residual to create a new model H1. Now, when you combine F0 and H1, that's what an ensemble of two trees, you get something we call F1. F1 is not a real model. It's just a combination of two trees, F0 and H1. And then you repeat multiple times. You keep doing this over and over again. I'm going to show you an example of how it reduces your loss. So you guys are going to see a practical example of how it reduces your loss. But the idea is that your new model F1 has a lower loss than the previous models. That's supposed to be the idea. So if you take the loss of the first F0 and the loss of the second tree, they're going to have like high loss. They're going to have very high values for loss. The combination of their two values is going to be greater than the F1, the combination of them as a tree. So the idea is that you're supposed to be combining these things we call weak learners. Each tree is a weak learner. Each tree doesn't have a big, each tree has a big loss, right? When you combine them together as an ensemble of trees, the ensemble is going to have a smaller loss. You're supposed to repeat this, and every repetition is going to be making your loss smaller. That's what gradient boosting is. It's just a method of getting a smaller loss eventually by splitting your data set. So let's look through an example. Let's say you have this simple example here, right? You have years. You are trying to use years to predict salary. Very simple, right? So if you use 5 years, your salary should be 82. If you use 40 years, your salary should be a lot, 166. The years of experience at his job, right? So the smaller the years of experience, the higher the loss. The smaller the salary. So let's create a simple tree. Let's say we have a tree that says for every let's say the tree doesn't split at all. This simple tree, this first tree doesn't split at all. This tree gives the same score for everybody. This tree assumes that everybody is earning 134 as a salary, right? Yeah, this is where we shall have a marker. This tree just put everybody in the same leaf, right? It's the first leaf. We call it F1. So can you see this tree is wrong, right? But you can check the residual or the loss of the tree by looking at the difference between Y and F0. So Y minus F0, that's your residual. Can you see your residual? So you guys can go through this example on your own while I move through. So look at that. That's what the tree is. Y minus F0 is the residual, right? So you now use the residual. You use the residual to create a new tree called H1, right? H1 is your new tree. And the logic of your new tree is that your new tree says what? X that is less than or equals 23 should be in this category, should have this value. And X that's greater than 23 should have this value. You get the first tree assigned the same value for everybody. The second tree, H1, uses the error of the first tree to create a better tree. by splitting the data this way. And when it splits the data this way, you can see a table. So using this residual value, you can see H1 assign this value to this guy and assign this value to this guy. Now we have our model called F1. What's F1? F1 is combination of what? F0 and H1, right? So you add these two together, you get this F1, right? And then you do y minus F1, right? Y minus F1 gives you a new residual, right? And use the new residual to create a new tree called H2. I see it splits the data set using this logic, right? X less than 34 and all that. And then you create H3 using the residual of F2 and so on and so forth. What's the point? What's the point? Why are we saying this? The point is that if you do your calculations very well and you calculate the mean squared error, remember what mean squared error is? This residual, just square it and add them all together. You're going to notice that the mean squared error of your F0 is large, 1850. Did you see that the mean squared error is dropping? For F1 is lower, for F2 is lower, and for F3 is the lowest. So can you see by combining simple logic tree, each tree is not doing too much. Each tree is just splitting the data set with a very simple logic. Can you see that by combining the simple logic that just uses the residual of the previous tree, you're creating a better model? That's called gradient boosting. That's exactly how it works. That's the algorithm. Just this algorithm. And you get a better model. That's gradient boosting. XGBoost has gradient boosting, but it's slightly advanced because it considers regularization. That's why I talked to you about regularization. So it does this gradient boosting considering regularization. That's it. The combination of the gradient boosting algorithm I just showed you plus regularization. And you can see it uses an ensemble of trees. The ensemble of trees is that each tree is a weak learner, then it combines them together to form this big tree. And that's how it learns. That's all. How do you use it? As I said, using it is sweeter than you just call an XGBoost classifier. You just fit your model and you just train your model. And you have an accuracy score. You can check your accuracy score, metrics, and all that. Test data. That's all. That's how to use it. Very easy to use. Are we making progress? So, do you guys like what you're hearing? Did I lose you? Okay. So the other funny thing about XGBoost is that trees generally have lots of things we call hyperparameters. Yeah. And so you need to tune the hyperparameters. What hyperparameter tuning is very simple. What you're doing is that you need to find the right setting. So what's an example of an hyperparameter? Like this, the size of the trees. How many trees am I using? The depth of the trees, right? And all of those parameters, right? So the way we do it is that we can do something called grid search. So all your hyperparameters are like different variables. So a grid search, what a grid search is that it keeps one variable constant and changes another variable, keeps the next variable constant, changes another variable, and it does it step by step like that. It literally checks the space of your parameters one at a time. When I say space, what I mean is that the different values of like the variables, right? Different values of variables. So let's say we have two hyperparameters, like the size, the number of trees, and the size of the tree. Let's say the number of trees, 5. Number of trees, I try 5, 6, 7, right? The size of tree is maybe 2 and 3. So it means the space means I will try 5 and 2, 5 and 3. I'll try 6 and 2, 6 and 3, 7 and 2, 7 and 3. That's what it means. Like I'm checking all the combinations of the parameters. I'm checking them one by one. That's grid search. But who knows what the problem is? What's the problem with the grid search? Yeah, too much time. What if I have a large type, like combinations? Like let's say I have 10 hyperparameters, and each hyperparameter I have like, I want to try 20 settings with each. You get like, I can even go bigger. It can get bigger. It can get expensive. And that means I have to run a training for each one of them. So if your training becomes costlier, you can see how hyperparameter tuning now becomes stressful. So another method you could use is random. You could randomize. Now, the thing is, someone might be like, is that not a stupid idea? Oh, but like, it's not that stupid. It actually could get you into the right settings faster. You're sampling, you're trying out different kind of combination of your hyperparameters, but you could get to the right settings. You could luckily get to the right settings. I mean, not just luck. There's a little bit of mathematical proof that shows that this might get you something faster. It won't be the best, but it might. The luck is a pretty good luck. It is pretty good. It would luckily get you there faster than this guy might. It might not get you to the optimal stuff. It might get you somewhere better in few runs. But there's another smarter one called Bayesian optimization. Bayesian optimization uses the distribution of the data set and the space you're in to know the right directions to go. It uses the idea of uncertainty and certainty and like the distribution of the variables or parameters and the space to know the right direction to go. So Bayesian optimization is a very, very smart idea. Okay. And how do you do hyperparameter tuning? You can use a tool called HyperOpt. You can use grid search. So you can use grid search from scikit-learn. Grid search is a tool for doing scikit-learn search. You can use grid search or you can use HyperOpt. HyperOpt is also very good. To do HyperOpt for Bayesian optimization. I don't have time for this. I'm not going to wait for them. But basically, you can see it's going to look for your best set of hyperparameters and give you the best score for them. And this one too will do its own search. So let's move on. Model explanation. Why is model explanation important? Does anybody know? Yeah. I work in finance industry, right? Yeah. And you can tell a CEO that, hey, my model just thinks this person is fraudulent. Or my model just thinks this person will default. No, you can't say that. No one's going to take that from you. You can't just say, oh, my model just thinks person A should default. And that's a big decision because you know person A that you're defaulting is someone that actually is a real person. So this is where you need to understand the importance of what you do. You have a model that's telling an institution to not give money to a person. Is that a big thing or not? Is it a big deal? Very important. You're depriving someone of money. Do you not think it's important to have a reason why? Does it make sense? So you need to have a reason why. And that's why model explanation is important. You need to have a reason why. And one good way of doing this is something called Sharpe ratio. Okay. The good thing about Sharpe is that Sharpe gives feature importance. So Sharpe looks at all the features. So it does this method where, guys. So what the way they do it is that there's this simple method where you take all your features, and it's going to do this combination where it will remove one feature at a time. One feature at a time. And by removing one feature at a time, you can check the weight or the impact of removing that feature on the score, on the predictions you have. Do you understand? And then doing some sort of extra statistics on that, you can be able to tell what feature actually has the strongest influence on the prediction you have, right? That's one method of doing that. You can do it in such a way that you have something called local Sharpe. So there's global explanation and then there's local explanation. Global explanation means, for my own model, for my model training and all that, this feature is the most important and all that. But that's not usually very relevant for me because I usually, practically me at my job, I usually need to know why I don't want to know what feature in my own model, what feature is the most important. I don't care about that. I want to care about each row of prediction I make. Why does, for this particular prediction, what matters the most? What is wrong? The benefit of doing that is that if I can know the most influential features for that row of prediction, if an human being is doing an extra validation on what my model does, or they're doing extra investigation on what my model predicts, they can know exactly where to go and look at. And so when they know exactly where to go and look at, they can then see that, oh, we're not giving this person a loan. So imagine you have like hundreds of features, right? You can't tell them to look at everything. Do you get? But feature importance is going to help the human validator to say, okay, I'm looking at this particular feature. So this feature was the reason why this person should not get a loan. Do you get? Sometimes it's straightforward, and sometimes it's not straightforward, guys. It's stressful. Sometimes you can't offer a good explanation. Yeah. But that's the thing, you need to make your model is the one giving the credit score. Yeah. Yeah. Yes. That's the point. That's the advantage. But we're also working on like smarter ways. This is one of the places where we innovate at Pastel. For example, we're also working on like smarter ways of like doing the explanation. That's not like the research ways and all that, like smarter ways that are more practical in a real life setting. We will be doing our own due diligence of making publication. We would actually publish some of our methods. Yes, we would publish some of our methods when we have time to publish it. We have time to not make money, but we would publish. But we have like very, very smart ways of solving problems like this. Yeah. I want to do this model monitoring, but I'll just stop here. There's no point of moving on with that. So I think hyperparameter tuning is done. I use the hyperparameters to get a better model. This is the model explanation. Model explanation is very easy by code. You just import sharp, you get an explainer, and then you can give the sharp values, and then you can plot to see what features actually matter. Come on. Demo time.
There's a question that says, are there other ways to cross-check the result internally for the feature applied?
Unfortunately, the thing is that I'll just explain. Like, I say explanation is hard because sometimes, even though you check like one or two examples and they are good, you're deploying an AI model that is live, that sometimes like at that scale, you might not be able to look through all of your own examples and all that. So your explanation model probably has to be decently good, and it has to be correct about what it's saying, and you have to finger cross that your client, it points your client to the right place, because sometimes there are cases where it's not making sense, especially places where, I mean, the reason why you're using the model is because the model sees patterns that humans sometimes can't see. So sometimes your model is using really, really fine boundaries that a human can still validate and not make sense of it. So sometimes there are no explanation. It's still a black box model. And the reason why it's a black box is that it's fine. It's reading fine. The model is, think about your model as something that's reading fine, very, very fine, like boundaries and combination of variables that, except someone gives a strong signal about a certain feature as to why they behave that way, you might not be able to really get that. So let's talk about the final. Let me skip model monitoring. Let's talk about the final products and QAs. I'm putting this slide so that you guys can have points you want to ask questions. So let's do the final demo. It is nice to have your stuff working. Am I connected to the internet? I'm connected to the internet. Let's see. Interface is running. Did I run this again? So let's say our final product. I've built the model I've added the logic. So guys, just look at logic. Logic is very simple. So the run prediction model now has the model that we built. So I received the inputs. I created the data frame with the inputs. And then I make a prediction with my model prediction. And I return default if it is one and no default. So now my model has the actual deployed model. I can work with it here, or I can go to the public URL. Yeah. So now we can play with our model. Our model has been trained. Yeah, no defaults. I don't understand these people's charts. What do you mean by this class is classic? Okay, so these are our final demo. We have our deployed model. But guys, yeah. But what I was trying to say is that like this is a way to quickly prototype things and have something working very fast. You can see if I actually sit down to do this, I can probably have this model ready in 5 minutes. Do you understand? Is it the best model? Is it the most effective model? Probably not. But let's say I'm going to an investors meeting and I want to show them something. What do I have? Something. I have something. I can then make an argument that in order to have a better model, I need more features, I need richer data sets, I need more funding to get my data set and all that. So what's this person say Femi don't carry us going there? So guys, yeah, QA question and answer. Let me go back to this page. Yeah. I think it's an internal for their tool to like I need to find something.
Everyone should give feedback for the end of the day. We have feedback for.
So let me know. Do you have questions? Do you want to understand something better? You want to know how stressful my job is? What do you understand? Like, am I more stressed than Teju? Is Teju more stressed than me? Oh. Yeah. Yeah. Well, what's up? What's the question? You can ask.
So if you wanted to learn
When did you start learning machine learning?
Okay. Yeah, we're going to go here. My story is very nerdy though. I think I might just go the nerdy route again. Like, so what do I mean by that? Like my yeah, I think it's Andrew Ng course now. But that course is vigorous. It was in MATLAB. And yeah, I finished it and I did all the MATLAB stuff. It's not in Python. It was in MATLAB. I think so before I got to my final year, I used to do online courses. Like, everything has background, but like even before I used to do online courses, I used to.
I'm sorry. Please fill the feedback form. This is really important. I'll put it in chat if you're on your.
Yes, someone said MATLAB and Octave. Yes, please. Octave, yes. Yeah, you had MATLAB resource and Octave. I didn't touch Octave. I just touched MATLAB. But like, so I used to do online courses. Yeah. And I think that's the main culture like that I recommended. I always recommend like online courses. I used to do like I learned Python from online courses. I did machine learning from online courses. I think when I was finishing you, I had like 12 certificates. So I used to finish my online courses. Yeah. I used to finish them. So I wasn't doing them for sure. I used to finish them. And the reason why I used to finish them was because many people did Andrew Ng course, but most people don't finish. But I used to finish mine. So even when I got my first job as a backend engineer, I was still doing my courses, like the Andrew Range course, and I was learning on the side. So I was a backend engineer by day, ML students by night. Yeah. I used to live in Motion, and I used to go to the Lutz reading room, students reading room, to do my courses. Yeah. Yes. Fun stuff. Yeah, just honestly, like, just finish your courses. Like, yeah. Yeah. No, the reason is because I see many people that are interested in things, but people don't actually finish them. Like, so there's the excitement of starting. Like, I want to learn Python, I want to learn. There's the excitement of starting. And we see it in AI Saturday Lagos too. Our cohorts, at the beginning of our cohorts, many people are going to come to the classes, many people will come, everywhere will be full and all that. But we know that the people that are, I'll give you good testimonies. The people that are ending up at the end, like, they're all doing, like, those are people who know they're doing great. They're doing great with the fact that, like, just going through those stuff and finishing those things is hectic. But that's where, like, the benefit is. That's where you actually have the acquired skills. Do you get the idea? So many people start things. Not most people don't finish, but you have to, like, be dedicated to your stuff and finish them. Yeah. I'm sure there are many resources and materials you all know that are good that you're using. You understand? But actually finish them. The thing is that the journey of finishing them actually helps you to. So people are learning. This is structure. You need structure. And anytime I want to go and understand this today, some of the structures I'm learning in the past that helps me. So you need that structure. You need to go through a journey that structures you, that takes you through step 1, step 2, step 3, step 4, step 5. Yes, and the structure is going to work for you. It's going to kind of go back to that structure and pick up points in that structure to refresh your knowledge. You'll be like, I've heard this thing before. Where did I hear it? Remember where you heard it and all that. So those things just give you structure. So any structured learning. Let's just say. Yeah. I'm not sure if that's the best material to be. Yes, of course, but I think the deep learning specialization, I don't know if it's still that good or
yeah. It depends on the route, like that's more academic.
Oh, I see. Yeah. Oh, I see. Okay, as I said I will take a nerdy route. What I mean by nerdy route. What I mean by guys, let's separate it. Guys, let's separate what I mean by a nerdy route. Yeah. Guys. Hello. What I mean by a nerdy route, this is with me, respect to me. What I mean by nerdy route is that, like, I like maths, so mine would have more math, right? It would be more math stuff and all that. But I don't recommend that. I recommend it to Teju now, as I used to then. Yeah, I recommend to her now as I used to then, because she's in academia, and that's the language in academia. Yeah, and it helps me today. By the way, I don't need it for my job, but I mean, I can go to summer schools and understand what they're talking about. It's hard to do that. Yeah, so I used to go to Oxford Summer School every year. It's just maths and machine learning, and it's very math. I'm not using it for my day job, by the way. Like, I'm not using it directly for my day job. I use it indirectly. Like, it comes up, but it's not like my active everyday stuff, right? But it comes up. It comes up when I need to think, or when we need to create, or we need to innovate. Again, it does come up, but not in my day-to-day job. So that might be so. But to do my kind of job, you might not need to do that much, right? To do what Teju is doing, you need to do that much. So, but to do my kind of job, you might not need to do that much. You probably need to. So the way I taught you, smooth, using that intuition, you need a material that does things like that gives you intuition to the algorithms and how they work. And so when you're looking for materials, look for materials that do that. In fact, I think when we teach in AI Saturdays, we look for materials that do that. Our first class wasn't like that, though. When we first started, We're not like that. There was one class people used to sleep. Yeah, thank you.
You were saying try to finish once you started.
Mm.
Is there an example?
If it's the right material. So first source for it very well. Then if it's the right material and you think like do an overview, check the contents, figure that is the right one, picture what you will be like at the end of the course. And once you've gone through that decisioning and you start, then finish it. Yeah.
Okay, so
Okay.
this open AI everywhere.
Okay.
So I'm like, what's behind OpenAI?
Okay.
Points to user camp.
Okay.
I saw working with OpenAI.
Okay.
It was a course. I started exciting and pushing it and
Okay.
pushing it. The text I'm pushing it, the
Okay.
next thing. A project in planning a trip to Paris. Okay. And I wrote the code with what I know.
Okay.
Red flags everywhere. Before then, to befriend all the teachers.
Okay.
On LinkedIn.
Okay.
Taking this course, please, if I have any issue to do like that.
Okay. 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 Yeah. And they saw the red flags.
They're like, not in the right direction. You know, some of them were not even responding. Some of them were like, please do this. Maybe.
Oh, I see. Oh, I see.
Okay, so okay, if you can probably is here, you can December.
Okay. That's a long time. Yeah. 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 Do you want to say something? Yeah.
Was this your first session?
Code before. Have you coded before?
Python with university and also many machine because it's AI Saturday.
Okay.
Tell you.
Yeah, okay.
Because sometimes we jump to.
I cannot take it into
the part that is.
That's why I said structured learning.
So she made mention of data camp. There's something about data camp. Data camp is good.
Yeah.
But data camp is structured.
Yeah.
Right? You must follow that structure. If not, you will get frustrated at the end.
Yeah.
So, for example, they have learning paths, they have career paths and all that. So, if you can follow that career path, but they do repeat things. For example, data analytics, there's SQL, there's Python. If you do data engineering there, you will still see SQL, but they repeat. And the more you go through these things, the more you get conversant with them. So if you follow their career path, I think at some point you get used to this. So check this course. This is a course, not the career path, right? This course should be under a career path. Check. It might be step. It's not just a course.
Yeah, it's a part. Then they had the introduction and everything. I went through that and this is the next one I stopped.
I mean, one could always check the nature of because sometimes some structures are not well defined. Some are not well. Like some people, because the idea of the structure is to be like, I mean, we've also made mistakes in the past. You understand? For us, for example, when we're teaching the maths class, do you understand? It wasn't the best. Like we didn't need to. Like, and most people was not used for most people. Do you get? So we made mistakes. So sometimes some structures might have faults in them. Like especially if they ask you to do something that they didn't give you a prerequisite for, or didn't even tell that you should have that prerequisite. Do you get? So imagine the way we are in this class now that I'm teaching, and all of a sudden I start to pull up like Flask server, I start to build a Flask model, like out of the blues and all that. That's not good structure. Do you get? So wait, let's alternate between online and offline. Someone is raising their hand online. Oluwatobi.
Yeah,
Okay, can you speak very loudly? Very loud.
Okay. Can you hear me very loud and clear now?
Hear you clearly. We can hear you clearly. Yeah. Guys, listen
Okay.
up.
So mine is more focused on your job, your daily job aspects. I know you said you do solutions for fintech and all that. In terms of KYC AML, are they like solutions that you interface with and that helps with that for fintechs? Or is in terms of those that give out loans? I know for repayment structure, there can be some things, but in terms of KYC and AML, are there solutions that you can talk about and what it helps in that matter?
Okay, you know what? It's very personal, very private. You can
Oh,
talk
very
to.
private. Okay.
No, not very, very. Yes, we have solutions. we have solutions. We do have solutions for that. Okay. Oh, sure. Okay. Just talk to me privately. We do. Yes, we do have a product for that. I can talk to you
No problem.
if you're interested in something
Thank
like
you.
that. Yeah. So, yeah. For what? Smooth. Yeah.
So I wanted to ask for the minority.
Yeah.
Possible that when the minority it could replicate itself so much that it causes a classic balance. Why trying to just get the big classic balance? Why trying to
Oh, meaning overcompensate.
Yes.
Oh, okay. It's possible, but the thing is that you have control of like the ratio. So the algorithm allows you to control the ratio yourself. So it won't do that except you. And I think sometimes you would even throw an error in the code if you want to do that. But yeah. Okay, it wouldn't do that. Like you have control over that. So you wouldn't, the algorithm doesn't do that automatically.
Okay. Is Toby, do you still have a question?
I mean, there's still offline questions mostly.
No. I think I'm fine. Oh, sorry. Oh, my hand. Oh, yeah. I'm fine.
You got it.
Okay. I'll just direct it to the class. Oh.
Okay. So
yeah, we can take maybe a few more questions from the online audience and we can wrap up for the day online, and we'll spend the time, a few more minutes chatting with you before we bid you farewell for today. Victory, please speak.
Thank you very much. My question is that when is the next cohort starting? I mean, because you talked about cohorts and all of that. I've asked that question in the chat section, but I couldn't get any reactions to that. That was why.
I must have missed it, or we must have missed it. So we are planning the next cohort to be sometime this year, towards the end of the year. And we will be and we're going to share details soon, but most likely it will be a deep learning based cohort, so it will probably be focused on transformer neural network. So more like intermediate for people who have a little bit of machine learning knowledge.
No beginners.
Yeah, I mean, we'll probably focus on intermediate this year. Last year we did research cohort, and 2 years ago we did a data science and machine learning cohort.
I think we can do parallel.
Yeah.
Should do parallel.
So well,
there's resources there. People
that we still have like for the class we held 2 years ago, we have all of it on like video and everything. So I don't think most of those algorithms are outdated yet. They're machine learning and data science cohort. But more details
we can have like so we can do parallel.
We get a lot of interest, like beginner.
We can do parallel and just use recorded videos for
yeah, exactly. So maybe we can send out, maybe we can send out some what's it called? Some forms to see where people are at. It helps us to tailor the kind of resources. Can you remove your background? I'm trying to do it. It helps us to tailor the resources, but in our thinking, for the next cohort, we should try to do intermediate level, which means that you have gone through one or like 2 courses on machine learning or like introduction to data science, and then you want to know a bit more about deep learning itself, and we want to focus on NLP, like transformer architecture, to understand what powers a lot of the large language models these days. Is this something you would be interested in learning about, or where are you at? What kind of
I would love the beginner
like
version. I would
what?
love the beginner version. I said I would love the beginner version.
The beginner version. Okay.
Yeah.
Introduction to data science and machine learning.
Yes, ma'am.
Okay, so do we have other people in the room that also want introduction to data science and machine learning?
No, this one's intermediate.
Introduction to so everybody here is intermediate.
Yes, intermediate. Why are you not
Someone, Toby was asking if class continues next week. So
we have about 4 people online saying yes, yes, yes.
okay, I mean, it would be nice. It's been so long since we had that, but no, class does not continue next week. This is just a session that we put together because Femi and I are currently in the country. So Femi works at Pastor, as I said, and he lives in Canada. I work as a researcher. I'm a doctoral researcher, PhD in Germany. So I'm still in my 3rd year. I have not done. So we both sadly currently, I'm not sure if it's sadly, but we're currently not in the country. But we have my co-organizers, Simon and Ghana. Ghana is the CEO for Stylebit. Ghana, I would like to introduce you to come to introduce yourself so people know about your business.
Yes.
But there was okay, these are your customers. Okay. So Ghana, we've been together for more than 6 years now with Ghana. 7 actually. So Ghana joined our 2nd cohort, and we invited him to be one of the organizers. And since then we've been co-organizers. So he's one of the core organizers. At ASF Lagos, we have core organizers, and then we have organizers for the different cohorts that we run. So for the next cohorts we're going to run, we're going to send out a call for organizers. Past organizers will join, and new organizers we also onboard new people. But core organizers they're going nowhere. They're OG organizers still forever if they want to be. So I would like you to say a few things. And also, Simon, I'll call you and I'll introduce Shadrach as well, who's one of our organizers, but not currently he's not on the core team. But
he's working his way up.
Yeah. Not on the core team. Okay, please.
I don't know what to say, but yeah.
Yeah.
You're fine.
Yeah.
So my name is Ibrahim Ghana, and currently I'm building a fashion technology startup called Stylebit. So what we do is help fashion businesses with their operations. So I don't like to use the whole AI, but we kind of like plan to build stuff around that where people would maybe yeah, so with measurements type of thing. But currently what we do is help businesses, fashion businesses, optimize their processes. So not so people hear what we do and think is for like consumers, but it's basically focused for businesses, so fashion businesses, yeah.
And Ghana likes to be careful with the use of the word AI because he understands this more than most founders. He doesn't like to sprinkle it anywhere, except the action.
Except when he wants to collect money.
So is that Dr. Victor? Okay, yeah. So we also have a very special, I guess we promised you would bring in the director himself, whom without him, we would not be here. So this is a partnership with Need Hub. Now, I've known Dr. Victor for many years. It's like one of my very amazing, I can call you friend, Doctor, right?
Right.
So I would like you to, we have online audience and we have in person, just like to say a few words to
So, good afternoon, everyone. So sorry, I hope you enjoyed the day. Sorry that the rain disturbed everybody. I had to run to almost, I almost got Abeokuta. Came back, yes, because I have to go and drop my son. So, well, I don't have much to say, just to encourage you to keep building. Okay, keep learning first. I remember almost 20 years.
Food now.
Yeah. Yes, yeah, almost 7 years. And it's been a fantastic journey. Oriba, what's Oriba now? So many people have, I mean, they've grown through the process, 2 years out of it, and the whole ecosystem in Nigeria. And so what I'll just say is just keep learning. And when I say keep building, start building.
Building, yeah.
Keep building, yeah. Don't look at it like it's going to take a long time. Don't worry. Just start and keep building. Just a little thing. When we started here 4 years ago as well, it was as if, I mean, I don't know what I've said, shared it with your community before. I'm a lecturer, so I have my normal assignment to lecture, supervise PhD, supervise masters. So when I started here, I had no staff. So I will lock the door when I'm going to the class and come back. Now I don't even need to do much. I still do a lot. I have a number of staff now, and those that are familiar with it, they're always busy now. Just about within 4 years. What I'm trying to say is that start something, keep doing it, focus on it. Before you know it, it will be bigger than what you think. So I think I will stop there. Thank you. Thank you. Thank you. Big bros, I don't worry.
Okay.
So thank you.
Thank you so much, sir. Simon, I would like to invite you to say a few words.
Simon.
Yeah.
Who is that? Is right now?
That's true.
So dead for what's happening.
It was one of the first framework before Tiano. Yeah, that was my framework.
Okay, well,
Yeah, you don't forget something.
that the first cohort we went through computer vision. This was very technical, like Femi said. And Simon joined our first cohort, and he was one of the students for the first cohort. It was just me and Femi that were organizers. It was after that we also brought Simon onto on our team, and we like for the projects we grouped them, and they based on
frameworks.
Python framework. I was about
Yeah. It's my frameworks.
Some like frameworks, so we have Python, PyTorch, Tiano, and some other.
Team Tiano.
Yeah, so Simon was the lead, right? You were
I was the lead.
But Team Tiano.
Yeah.
It doesn't like we both forgetting about it. That was 7 years ago. So
yeah, that was 7 years ago. It's 7 or 8 years.
It's 7.
2018. Yeah.
What's the University of Hampshire after?
Yeah. All right, so my name is Simon Ubi. I'm part of the organizers. As she said, I joined the first cohort 2018. Just like you guys are starting up, that was how I was hungry to learn. So what inspired us then was automation, robotics, and all that, watching sci-fi movies, and so I wanted to do all those things, So I started as a C++, I started with C++, and it was something that was like, what am I doing here? So I wanted something, so I was searching for a community online, and I remember I stumbled upon a post on Facebook, about here I started. That was how I joined, and it was their first cohort. That was how I started with the cohort, and I don't regret it because somehow it has also helped me grow, right? I've been able to meet wonderful people like Teju, Femi, Oreva, George, Tayo, and the rest of them.
Those are other co-organizers.
Yeah, for other co-organizers. So one of the benefits is the ability to network, meet people like minds, and also to learn. I've also learned a lot, and it has also motivated me to keep on learning, right? And because of that, I dived into training. So I'm more of a trainer, right? I do a lot of training, and thanks to AI Saturday, yes, that door was opened because of AI Saturday. So I've trained a lot of people
and it has taken me to even Covenant University, right? So that is
We already have to deliver for spring, but we want like a very personal trainer.
the exercise is free, yeah, but we want personal trainer and all that. So I train institutions, even MTN. I've been able to like train MTN staff to the highest level, like a small boy like me, right? So it's the benefits of being in a community like this where you learn. And whatever you learn, you don't want to keep it to yourself. You also want to teach others. I used to tell people that the best way to learn is to teach. And that's how I learn. If I want to learn fast, if I just learn a topic, I want to teach it. If I don't teach it, I don't feel as if I've learned that thing until I pass that knowledge to somebody. So I also do side hustles. Like, I don't know if I should say this.
We are still live, but maybe afterwards.
All right,
Okay.
that's
Is also what's the co-founder?
Yes.
Co-founder, not was, of AI Saturdays Abuja.
Abuja, yeah.
When he was living in.
When I was still in Abuja, so we were running the AI Saturday quads in Abuja, and COVID happened, and
Yes, like
rest is history, like back home. All right, thank you guys.
Thank you, everyone. Shadrach, just one more, then we will release you. So I'd like to introduce Shadrach, or invite Shadrach to introduce himself to the class.
Hi, everyone. My name is Shadrach Adeyemi. I'll say this is a full circle moment, should I say it? Because I also joined, I think the 6th cohort, if I'm not, 6th cohort. So I joined as a participant. I'm a big fan of Tejuba,
No, Shadrach together.
So I joined and then I learned. It was big enough, I can't lie. Just like they said at the start, where we have a lot of people coming, and after a while, they just fade out. I think during my own particular cohort, what's his name now? The Yoruba Asian. I'm trying to remember. Yes. He was one of the people that I think one of the labs or classes that I had. Yeah, lives in Canada now.
Yes.
Yeah. So he was like, because we always have study groups, or different subgroups in AI happening. So he was the one heading mine. And you can't, today is tough, man. They do stuff, very tough. Very tough. So where I'm driving at is, a lot of people kind of left after a while, but we that stayed, I mean, we benefited from it. I currently work as a data and analytics consultant with an Italian firm, although we have fiscal office in Lagos here. We are hiring, by the way. You're interested, I think. Nice, I tell people.
You see this here online. This company is hiring. So if you're looking for a job.
What they do is they outsource AI talents for European companies.
Sorry, can we keep it light so we can hear Shadrach?
It's good that I say it's in a community, so
yeah.
So it benefits the community because Tejo always shares stuff for community. So I'm happy to be here. Like I said, full circle moment because I'm learning to co-organize. Nice.
So yeah, there's a
nice
question.
to meet everyone. Jada, JADA.
So JADA, Jada. So the name of the company is Jada. You can look it up, and there's opening. If you're applying, let us know. Yeah.
So you have to be at least 2+ years.
Okay.
It's not popular.
So yeah, it's called Jada.
Yeah.
How can you reach out? So you can reach out to us on we have Slack and we have Discord and we have Google Groups. That's much more active. So make sure you join us on Google Group. And so I think that's it for today officially. So we can release online audience. Thank you so much, Femicom. Everyone come, organizers, come and say hello. Let's see. So okay, thank you. Thank you so much for joining us today. And we bid you farewell wherever you are. Keep learning, keep building, and let us know what you're up to.
Look at that.
Thank you so much, Femi and Aziz. Mr. Simon, good to see you.
Hi.
I didn't know you've left us.
I'm the only one I know Philip is online.
Ibrahim, and I'm like, this time.
I did have fun now.
Thank you.
Simon. Alpha. Guys, well done, well done.
Bye, guys.
Oh my god, that's George, right? Oh yeah, no, that's Gideon. Gideon. Bye everyone.
Bye.
See you again in person. Bye.